Okay. Hey, we got people filing in already. Okay. What's up? Let's go 3. We'll do. Hello, hello. We'll do 10 minutes from now. So 15. What up? Get money. What's up, Blurcat? This is Radical Chris. Ooh, another Andrew K. Crypto code. Everyone's coming in. Oh, Jens is here. What up, Jens? Okay, async. Await. Resurrection. Hello, hello. Welcome. Ryan Liptak's here. What up? Matthew's here. Second half. Try to hook up IOU ring. So it'll give you fun in the beginning. We'll give everyone some. It'll be like more engaging, and then the first half, and then the second half will just kind of peter off into programming land. But I'm gonna go make a pot of tea. I'll be back. 6 minutes might have been a bit ambitious, but let me see what I can do. Oh no! Missed it. All right. Well, we can get started. How's everyone doing? How many people got here? 150 people watching? Wow, okay. Let's have a nice stream. So, welcome everyone. It's been a while since I streamed regularly. Truth be told, it's because my computer kept crashing. And the great news I have now is that it stopped crashing. Holy shit, 27 days of uptime. Blowing my mind. Used to crash like every day. So, we're doing great. Fun fact, in order to make my computer not crash, it's not a Linux moment. It was a defect in the motherboard where the networking chip would overheat and then malfunction, and then the kernel wouldn't be able to read from the hardware. To fix it, I disabled TCP checksum offloading. So there's a feature on the motherboard where it's trying to use the hardware to do part of the networking stack, but it just generates like a little bit of heat, and that heat just was too much, and it was just fucking it up. I didn't think of this. Jacob Young told me to try this, and I was like, what the hell? There's no way that's going to work. And it totally worked. So basically, I just moved some of the networking stack into software, and now that component doesn't generate as much heat, so now it doesn't malfunction anymore. Here we are. It works. Oh, I also dragged a long cable through my house from the router to my computer. So I'm on like a nice wired connection now. Yeah, it was happening with wired too. I had to do both. Okay, but anyway, that aside, let's get back to the topic here. So, where do we start? We lost async a while ago. I think it was 0. That's not the one I wanted. I think it was 0.11. Let's see. Async functions. Okay, they regressed in 0.11. We had them in 0.10. Yeah, so it's been a while. That didn't happen. They didn't get restored. They've been broken for many versions now. People keep asking me about it, and I didn't have a good answer. But I think it's all starting to come together. So, where do we start? Well, there's so many it's like a big mesh of connected components, and they all affect each other, and I'm trying to figure out where we should start looking. Well, part of it comes down to recursion. Does everyone remember this issue? There it is. Okay, so this is probably not what's going to be accepted because it relied on async. But let's start here. So everyone loves recursion, right? If you don't love recursion, you probably just have never used it before. It's great. The problem is it has a runtime known bound on the amount of stack space that it needs to use. Okay. Good morning, Ish. Yeah, I realized my Ish on that announcement was extremely load bearing, so thank you for waiting. Here we are. We got a stream. Okay. Anyway, so we have runtime known bounded stack usage. That's the problem. Now, the problem with that is that if you're recursing over user inputs, which is often the case, so for example, I don't know, say you're a parser and you're parsing over a file. That's user input. Or what else do we use recursion on? I don't know. Everyone knows this. I don't need to go over this. Point is, There's a problem. So you can try and rewrite your code to be loops, or you can use an explicit stack. But man, recursion, it's just so gosh darn convenient. Now, the thing is, this accepted proposal, the idea was that if a call graph cycle loop is detected, it forces you to use async await. And that did solve the problem, because it would force you to then use async call and pass your buffer differently. This never was actually implemented, though. Problem is, this also still required the function to be having the async calling convention, which is not ideal. So the question kind of starts with, what if we could solve safe recursion in a better way? And it ties in with this issue that that Jacob just opened. Recently updated. Oh man, there's so much activity here. Okay. This is an example of a call graph cycle right here. If there's no call graph cycle, you can calculate the upper bound of the stack by just analyzing all the functions and taking just adding them all together. And then you won't have a stack overflow happen. But problem is function pointers too. So recursion and function pointers also go hand in hand. Also extern functions. Oh man, I don't know. I feel like I'm not starting on this on the right point. My thoughts are so disorganized about all this. I'm just gonna hit all the points and then we can try and drive it home. Okay, so the point is, we could solve safe recursion with a new stack call. So if there's a call graph cycle, you're gonna have to use a some kind of built-in to make the recursive call. Now, function pointers can be solved because what we can do is we can track all of the possible callees in each function pointer. It's actually quite possible, and this is a nice proposal that outlines it. We're still kind of hammering through the details here, and I'm kind of arguing with... Come on. What? Oh, I see the problem here. It's like a KDE annoyance. Still hammering through some of the details here, but it's kind of a foregone conclusion that something like this is going to exist. And the point is that with this, when you have a function pointer, the compiler is going to know that the callee is either going to be one of these fixed set of things. And that allows it to take the max of all of the stacks, the upper bound stacks of all of those. Combine that with a global setting for how much stack space external functions are supposed to use, and we have ourselves a known stack size for the entire call graph. So, with that in mind, I thought that it would be worthwhile to revisit the other way to implement non-blocking I/O, which is with userland threads, or in other words, stack full coroutines instead of stack less coroutines, which they were before. People have already done implementations like this before. So for example, I was just looking at this one the other day. I think this one basically works. So people have already done work on this, and basically what it comes down to is that you can implement async await in userland, and it actually is like pretty handy. It's not bad actually. So let's try this. I think maybe. Oh, libcoro. There it is. So yeah, there it is. Look, this person implements async and await in userland, and it's done with this primitive where you well, it looks different on the different architectures, but you basically have a primitive where you just swap the context on the CPU without going into the kernel. There's portability issues with this, but it's a technique that's quite useful. And then in this case, it's kind of like how Go works. So you still have stacks for all these things, and they're just kind of do the same. Like the code just kind of looks the same as it does before, except you can pause it now and resume it. So we've been exploring doing that doing async await in userland. And then the other key change that I have in store that in my mind is a foregone conclusion is the idea that all I/O will have to go through an interface, just like allocator. So here we have only async await defined in here, but you can imagine read, write, sleep, receive from, accept, bind, all networking, all file systems, all timers, all I/O goes in here. It's dependency injection once again, and it's the same thing as allocator. It's just for all I/O. And so what you end up with is basically if you want to make a package for other people to consume, like maybe I just want to make a like a JPEG loading library. That's all it does, you know? Well, the JPEG loading library wants to provide the abstraction over how JPEG images works. It doesn't want to make a choice on your behalf on how you access the file system. So if I'm making a JPEG, oh, I didn't mean to make this change. Sorry. If I'm making a JPEG loading library, I don't want to require my users to then use blocking I/O, or I don't want to require my users to use non-blocking I/O. I don't want to require them to use Windows IOCP. I don't want to require them to use libiouring. I just want to explain how JPEGs work so that no one else has to, in terms of code. You know, you may recall the purpose of Zig from the home page. One of the core things that we're trying to do is reusable. That's a serious goal, you know, it's not a joke. So if you make a JPEG library, it's got to be able to support being plugged in to anywhere. Got to be able to use it in freestanding and in any architecture. And so we want to be able to make it work in all of these contexts. That's been the plan all along. So by having this I/O interface, which I'm working on, and if you make your package updated to use the I/O interface and all your I/O goes through it, you're being more friendly to being reused, because now you're going to participate correctly. Like if the application wants to do single threaded blocking, it's going to work correctly. If the application wants to do single threaded event loop, it's going to work correctly. It's not going to block on I/O. It's not going to use more than one thread. If the application wants to use multi-threaded event loop, it's going to work correctly. And you can even express doing things in parallel. So you can say, do start this operation, start this operation. We can implement await. And we do this in our, for example, our JPEG package. And it will just lower correctly no matter which way the application has chosen to set up their I/O. So, and the same thing as setting up an allocator, you can choose implementation. So, for example, right now I can show you. So I have, let's pick this allocator. So I have an implementation of, this interface that's based on a thread pool. So it literally just is the thread pool standard library logic, except now it satisfies the async and await I/O vtable. So now we can run this code, and I can run that below here. I think think horizontal is the move for the stream. There we go. So let's do build exe, and I can run that. Oh, we got a invalid free. That's not good. Let's go take a look at that. Must have left this in a state half done or something. Okay, so I've been collaborating with Jacob Lee on this, and I think we didn't coordinate on one of the changes or something. Okay, so we said this shouldn't be freed. Oh yeah, that makes sense. That size is wrong. So how much size do we? I need result offset. I guess I have to store the length too, don't I? Okay, really quick, let me just fix this. Okay, and then the amount of free is going to be base plus oh, this mem copy is wrong too. Hold on. There we go. And then we need, oh, we already have the result len. We don't need to store it again. Sorry, let me just fix this up really quick. It's just going to bother me if I don't just do it real quick, like 20 seconds. So then we do, is the result the last thing? Yes. Okay, so then we do base plus result offset. Then I think it's yeah, one sec. Let me just get this fixed. So we need the length, and it's gonna be result offset plus result len. Oh, that's stored actually. Right. Okay, I think that's gonna solve the problem. Let's try that out. Okay, sorry about that. Yeah, I'll make the font bigger. Thanks for letting me know. Okay, so where was I? My point, I'm showing you this example code here. So we have this async here, we have this async here, and then we do await. And my point is that this is our user code that is agnostic to the implementation of the IO interface. So my point is that, so here I did it with a thread pool, where we spawn all these threads, and then every time you do async, it just spawns a thread, and every time you do await, it waits for the thread to finish. Okay, but I can also swap out that with a different implementation. Ah, shit, with a different implementation. So I commented out the thread pool one, and I uncommented out this event loop one. So now I can build that. And this is just more debug output, but you can see we get the same results here. There. And in this case, this is a multi-threaded, this is a MN fibers implementation or green threads implementation where there are threads and there's also userland thread switching. So like the first time you, let's see. Yeah, the first time you do async, it might spawn a thread. Actually, so in async, we allocate a fiber or we recycle one, and we prepare for switching to it, and then we schedule it, and then we return. And then schedule is going to spawn a thread if we are not at capacity. If we are at capacity, then it's just going to append the fiber to the queue for scheduling right there. Well, it's queued either way. And then we spawn a thread if we're not at capacity. That makes sense. So then later when we do await, where's that implementation? Here we are. First we check if it's eagerly done already, and if that's already done, then we have nothing to do. Then we do this. We might find out that because we might have to wait, right? Obviously it's a wait. So if we have to wait, we put our own fiber into the structure, and then we yield. And then the yield is the interesting part. So yield, yield creates this switch message, and then we go into the juicy part where we have this inline volatile assembly that swaps around the CPU context. So obviously this will have to be implemented differently on different operating systems. And then there's one more little component here that's needed. Anyway, point is this can all be done in userland, and what the Zig project can offer, because everyone can already be doing this, in the ecosystem. But the important thing is we need people to coordinate on an interface, right? That's the key point. So I think what we need to offer in the standard library is this IO interface, and we'll need to grow other stuff too: read, write, file operations, networking, all that stuff. Also, reader and writer plays into this too. So if we can provide this interface, and then packages can use this higher level IO thing, and they can then play nicely with these different implementations. Applications can choose their own implementation. They could use this one that we provide in the standard library. They could use a simpler one like the thread pull one I showed you, or they can use their own custom one. And the nice thing is that they can choose how they want to lower all these functions. And it's also good for testing, like you can, if you have IO as a parameter, obviously that makes your unit tests more powerful. So I'm pretty sure at this point we definitely want to have this IO interface and try to have pretty much all IO go through it if it's not implementing like the lowest level stuff. You know what I mean? Okay, so I think I put enough on the table to get your brain juices flowing. So let me go back through the backlog here and see if there's any questions that I missed. Because there's still more stuff to talk about, but I feel like I'm kind of going around in circles. So maybe I can use chat to help me figure out like what should we talk about next, like what's not clear, what's confusing, like what questions did this raise. We can go explore those. But I think I'm at least kind of starting to give you the idea of where this is going. So let me scroll up a little bit. I saw one question that I just wanted to answer really quick. Why not Ghosty? I don't remember where it went. But yeah, I'm using console here. The problem is that when I use Ghosty, I think I can spawn it and show you right now. This is an old version. I don't know if it'll work. Okay, well, doesn't matter. The point is that there's a bug, not in Ghosty, but in KDE, that makes my core usage show 100% for every window open that uses Ghosty. I think it has to do with IOU ring. Anyway, it's going to be fixed in the next KDE version, and then I'll start trying to use Ghosty. But until then, it just bothers me because I see this false positive core usage and it drives me nuts. Yeah. I also use search sometimes, like this feature where you find something in the terminal. But I don't know. Honestly, I have to admit, like, I'm not a terminal nerd. Like, I kind of am just fine with all of the terminals. So if you are a terminal nerd, that's great. I'm just I'm kind of focused on other stuff, so I just don't really care too much. Okay, I see a lot of questions. All right, look, I'm sorry, everyone. I skipped over everything. If you had a question about the async 08 stuff, can you repeat it? And I will go over it right now. Oh, hey, Loris. How you doing? I haven't caught you on one of my streams in a while. Hey, Jim. It's good to see you here. Yeah. Hey, for those who don't know, Jim Calabro is working on a debugger written in Zig. There was that Showtime episode that they did recently. That was pretty sweet. Looking forward to trying that out some more, too. Question. U-ring is good. ePoll not good enough? Well, we're going to try U-ring today. Don't worry. Is it a problem if ZeroGen errors on integer little... You sound like you're trying to take over my stream, Matthew. Well, do your own stream on ZeroGen. I'll come say hi. Console is pretty solid. I am pretty happy with console, actually. I think when console is omitted from like terminal comparison tables, I feel like it's being slept on. You know, don't sleep on console. It's actually really good. It is memory hungry as fuck, though. I mean, look at this. Processes, applications, maybe. There it is. Yeah, like that's a lot of memory for a terminal. When I was using, I used to use XFCE before this, and XFCE terminal was always at like 30 megabytes or something, just always, no matter what. So async would stop being a keyword. Yeah, that's the idea. So this is an exploration of doing these. Let me back up. The purpose of the keywords, the purpose of the language features, async await, was always the same. It was always this use case. We have a package that wants to provide some abstraction. But that abstraction is not trying to do anything with the file system or networking or whatever. It's just trying to give you support for this file format, or support for, or maybe it does need to do something with networking, but it's not trying to take over your event loop and decide how that's supposed to work. It just wants to fit in with your application, because your application could be designed in different ways. So it's trying to promote this code reusability. That has been the use case all along. And so whether that's a language feature or it's implemented in the standard library, it's not the main point. So this is an exploration of whether or not this use case can be satisfied, can be handled satisfactorily without the language feature. And if so, then that's nice. And in a minute, remind me if I forget, because I'm going to get into two more topics. One of them is cancellation, and one of them is select, aka like waiting for multiple futures. And I have a pretty strong case that the userland notation is more viable. Would it be multiple interfaces depending on the type? Yeah, I was thinking about this. I don't have a perfect answer to this. I think the simplest thing is that I/O is just a big grab bag full of everything. So it would have file system and networking in there. I do think that it would be worthwhile or typical to either have some of the functions be nullable or have them just like return error dot not supported or something. For like, you can imagine that I want to pass an IO interface to one of my dependencies, and I don't want them to do any networking at all. So I just disable the networking functionality. So now if a package calls, a receive message, it just gets an error or it crashes or something. And that wouldn't be for security purposes. That would be mainly for just, it would just be nice to know, like, oh, I'm just sure that they're not doing any of that stuff because they shouldn't. And it would also just prevent those functions from being called if you didn't want them to be implemented at all. You don't want that code in your binary. So it's hard to articulate the benefits of turning off subcategories of stuff, but I think it's kind of an intuitive benefit. But as far as having the interfaces be like actually separate, I don't know if that works, because at the very least you're going to want to have like this, for example, in this implementation, this event loop. I didn't do it yet, but I want to add like IO ring to this, or epoll, or a different thing on Windows or whatnot. So, oh, excuse me. Sorry, I have COVID right now. Where am I going with this? Yeah, I mean, you do want you want this state to have access to all of the IO, because it's relevant. So like if the application is both waiting on networking and the file system, you want it to register both in the same like IO ring, and then find out when one of them's done so it can resolve the future. So they do have to be kind of implemented together. So then the question is, like, do we try to separate them out just to make it nice or whatever? I don't know. I think that's just kind of like one of the things you figure out at the end. But the null hypothesis, as far as I'm concerned, is just a big grab bag. Potentially with some of the functions, just set to null or set to like return error not supported or something like that. Okay, next question. Sorry, I know I'm probably going a lot slower than they're coming in. Is this something you plan on using in the compiler? Is that why it's being brought into standard? Not really. I do think that this interface is pretty well contained, though, especially if the IO starts going in there. So, well, anyway, to directly answer your question, it's not motivated by wanting to be used. It's just motivated by the fact that I had a couple weeks of vacation to just deal with some personal stuff. So then my brain just kind of wandered over to the unsolved problem that I wasn't thinking about first, just because I don't know, I just got a little burnt out on some of the release stuff. So I just kind of switched tasks subconsciously and started thinking about this stuff. So point being, it comes from just a motivation of solving the last puzzle piece of the language, and just having a plan. So I don't think I will, like, once I prove this concept, I don't think I'll even push forward on it until some of these other higher priority roadmap things are done. I don't think I'm going to rearrange the roadmap. I just think that I can push out a proof of concept that solves the last puzzle piece of the language. That's the motivation. Now, that said, I do think that this IO abstraction and the reader-writer one that I'm working on in the other branch, they're pretty nice. So as soon as they're available, I would definitely just switch over and start using them everywhere. I mean, the goal, it's important that we just get everyone to use the IO interface as the high level preferred interface to use. We don't want people just reaching in to make blocking syscalls when they should take an IO parameter and participate, collaboratively in the IO strategy for the application. So we need to get everyone to cooperate and use an interface so that applications can choose how the IO is supposed to work. And I think that can all happen in userland, but we just need to have the convention that you got to do your IO through a parameter, just like we already have the convention that you got to do all your allocations through a parameter. Now, the Problem is that we had the benefit of having the convention of allocator be the convention since the very beginning. Now we're going to have people probably resisting this concept and doing it multiple ways. So now we have like we have the problem that Zig exists and is, to whatever degree popular it is, it prevents people from wanting to switch to having an IO parameter. But that's kind of what we got to get everyone to do. And I'm fully convinced that is the path forward. It's like allocator as a parameter is more sus than IO as a parameter. IO as a parameter is like even more obvious than allocator as a parameter, in my opinion. I don't know. It wasn't obvious to me until too late. Okay, let's move on. Is this a resurrection of the original async design? It's different. The original one was stack less. This one is stack full. I don't have any plans for generators. My other question was, have we thought about how to debug the code? Oh, that's a great question. Custom debugger code. That's the only way, as far as I can tell. I mean, we already need that, you know. We didn't have the ability to look at hash maps or multi-array list or stuff like that until Jacob added it to the LLDB fork. It just has hard-coded support for the standard library stuff in there. I think you just need that. So I think you would just also need that for this stuff. I mean, it's a standard library, you know, it's the same thing, adding support for hash map, adding support for the format that, you know, the green threads are provided by the standard library. It's kind of the same concept, right? I think there's no way around that. I mean, we do have a language code for Zig in Dwarf, so that's a start. We use that in the self-hosted backend. If only there was someone here who was working on a debugger. Hey King, what's up? What's the stance on stackless coroutines? Well, they don't exist, and if this works well, then they probably will never exist. What about WebAssembly? Yeah, so WebAssembly doesn't have the ability to do something like this. Like, you would just not be able to translate this into WebAssembly. You would need, you would not be able to implement this implementation of the interface. However, you would be able to implement the thread pool one. This one would just work. So point being that this same code, again, the usage code, like, again, if you just wrote like a JPEG package or something, it would work in WebAssembly. You just wouldn't be able to use this one. You'd be stuck with this one, or a single threaded blocking one. In which case, every time you did async, it just did the work immediately and then awaits or no ops. So, I mean, that's a good point. Like, there is a use case for some targets where if you want to try to like do an async on a function and then ultimately it wants to call like a JavaScript function, that's not supported by this because you can't solve that in userland. So that's a trade-off. That's something that worked asterisk in the previous, well, that was something that works by having async await in the language as stackless coroutines, and it's something that doesn't work when you delete that feature, which is what this is. Now, that said, the previous implementation had this pretty nasty flaw that I think was never solved. And it was async call. So if you had a function pointer, aka you only know at runtime what function you might be calling, you had to use this built-in, and it was awkward as all hell to use. Pretty much just like a non-starter. And it was the reason that we used generics instead of instead of function pointers for reader and writer, because it was just so much of a pain in the ass to use this function. Now, this is something that we're addressing with restricted function types. So by having function pointers know the possible set of callees, it could be made better. But I'm just pointing out that there were some unsolved problems there. But that's pretty much a trade-off. So you lose the ability to use an abstraction like this on WebAssembly. You can still have reusable code. You just have to have a different implementation. And then you gain the convenience of using functions that are like normal functions interacting normally. You gain the benefits of stackful functions. One more thing though, so browser-based WebAssembly would have that issue. But if you're using WebAssembly in other contexts where you control the environment, you actually could export. Basically, you could implement this as like a native add-on, and then export a function that provides this primitive, and then you would be able to implement something like this on WebAssembly if you control the environment. If you don't, then it's different. Okay, I think I'm scrolled way up, so sorry for missing everyone's questions. I'm going to just skip over. Repeat it if I missed it and you want to hear it. I'm just going to try and catch up. That's how queues work, you know. Once it gets too long, you got to just start dropping packets, you know. Oh, hey. Wait, I'm going to fuck up your name, aren't I? Rocker Rager, right? How would you handle things like IO CTLS? What is that? Show my test code. There you go. IO CTLS. What is that? This is like a miscellaneous function. So which one are you specifically talking about? Oh, say I need to tell Titty to be in raw mode. Okay, so IOCTLS. Let's just look at what that actually does. So let's dive in. What's the actual syscall here? How do you tell a titty to be in raw mode? Is there a link to see the code for the proposed async interface? Yeah, it's this file, and it's in a branch async await demo in the Zig repository. Oh, we already answered that. Thank you, Andrew K, fellow Andrew K. I still think that allowing Zig to call async JS function is really important. Okay, fair opinion. Is there a way to union together these interfaces, like how we can union together error sets? Okay, cancellation is a good topic to get to. So, I mean, let me try and answer this better. Where were we? Here we go. Okay, so IO console is not a real syscall. What goes in this interface is the lower level stuff that actually interacts with the syscall that is blocking or not blocking. So some IO console stuff is just like doing a read or a write on a file descriptor. In that case, there will be a higher level similar to IO console API that takes an IO interface parameter and then lowers to those calls. I can show you if you can just find me an example. I don't see any like set. Is it in here? I don't think there's one here. Anyway, it lowers to primitives. The primitives will be in here. The higher level API will be basically the same. It will just also take a IO interface parameter, just like a lot of functions take an allocator parameter. Does that make sense? Repeating question: would standard IO have windowing of some sort? I don't know what that means. You mean like Windows? Is that what we're talking about? No. It would certainly not have that. It has the low-level IO primitives. Windowing would be built on top of that, and it would require taking an IO parameter. What do I make of this popular async IO package? Let's take a look. Cloud Def Zig AIO. That's the one. What's this? It's got its own website. Wow, that's pretty. Okay, so right off the bat, I'm seeing that we're opening these files directly. We're not using IO, non-blocking IO to do that. So we've already missed the point. But maybe that's just for a simple demonstration here. I don't know. I don't really have an opinion about this. To be honest, I just kind of know what to build. And if I need help with the implementation, it's nice to look at other implementations, but it's easier to build the interface from first principles than it is to start with just a grab bag of other people's work and then try to make the union of that or something. Okay, people have a lot of questions. Are we ready to move on, or do we have a lot more? Do we still want to try and ask more questions? I think we got to talk about cancellation and select. So the way that prioritization and scheduling would work is that the application is the one that decides which implementation to use. So if I choose to use this implementation, now I have access to this object. This is my scheduler. And this is where I would then expose some kind of prioritization, scheduling API, configurability, whatever, because that's the logic that does it. So that would be the application making these kinds of choices, and the usage code, which is just given one of these, is agnostic and does not have access to this object. It's just doing the operations. So yeah, I mean, there you have it. So you might be able to do something like where you offer an IO object and you've set it up such that it will register everything that happens at a lower priority or a higher priority. And the usage code will just be completely agnostic to that. So that's something that this pattern enables, actually. Async Rust. It's trivial in a debugger. Oh, okay, yeah, debugging. Okay, it's trivial in a debugger to add support for visualizing common data types. It's not so easy to do a step in to the invocation of an async function and have it gracefully find the line you really wanted to go to. Are you talking about async Rust functions? I mean, the question that would be relevant here would be, I mean, it's green threads. Like, how hard is it to add support for green threads in a debugger? Because that's the problem that we're facing, basically. Did you see my workaround for async in the browser? To make my workaround suck less, I would need a way to store the stack and resume it. Yeah, I'm aware of that. That is something that the previous implementation where the language supported async await with stackless coroutines, that worked in the browser. Let's keep going. So that would be the choices of standard IO. Yeah. Oh, Loris is gaining all kinds of new knowledge. Terminals, parsing. Damn. Did I see Java released virtual threads without pinning last week? No, I haven't been paying any attention to what Java's been doing. Virtual threads without pinning. What's the key takeaway there? Will this support fully in-memory file system for testing purposes? Yes, that is another use case it would enable. You offer a I/O implementation to a function, and all of your file system operations go through a middleman or just through a shim or whatever you want to call it, and then you get nice testing. So yeah, that's another thing that this enables. Well, we can just have a look at how debugging this looks. So I'll switch over to the fibers implementation here, and let's step through it. So let's build this. Is this the one I want? No, I just did the wrong thing. Okay, so let's do an example step through. So what's the use case here? Let's get Jim. I'll zoom down here. So should we put a breakpoint in here, for example? Where do we want to put the breakpoint? Okay, so we can break on zing line 32, run. Okay. Let's do finish, I guess. Finish. Okay, so now we're in the 347 IO. Oops. Oh no, we're in here. This is part of the async call function, so we can finish. Okay, so the problem is that you step through your schedule logic and a branch to get back to your application logic. Okay, I'm in. Could not create return address breakpoint. So, right, so there's a problem. Finish doesn't work here because we're about to yield. So if we do like next, we don't end up going, oops. What did I just do? We don't end up going to the next line, so next doesn't work from there either. And we just end up doing the whole rest of the program. So that's the problem you're pointing out, right? Yeah. Yeah, and if that's in user land, for example, then it could be quite tricky to try and integrate that into a debugger. Okay, so that's a trade-off as well. That's good to point out. So far we've pointed out the WebAssembly in the browser use case is not quite as nice. We've pointed out this use case wasn't nice with stackless coroutines either. So I don't know if that's even a trade-off. That's just kind of an issue with async await in general. Would love to figure out how to make that work with debuggers, because we do need the ability to communicate like non-blocking concurrency, so let's just have debugging technology catch up, if you know what I mean. Like, just get good. Where am I going with this? Okay, so let's talk about, all right, 3 things. And then we'll do and look, it goes both ways, like I want debuggers to step up, but also you don't have to work with only exactly what debug info we're giving you today. If you want, if you're like, fine, like I'll make it a better debugger, but you got to give me more debug info. You got to give me more to work with. Like, great, let's do that. You want to come up with an extension to Dwarf that we will add more information so you can make it work better? Let's do it. Let's collaborate. You know what I mean? Let's just both set higher standards and then let's achieve it together. That's my perspective. Okay, so 3 things. One, I want to make an argument that why this is the path forward, whether or not we decide to resurrect the language syntax for async await, whether or not we decide to resurrect stack-less coroutines. I want to make an argument that this is still the path forward first. Next, we're going to talk about cancellation. Next, we'll talk about select. Okay? So, okay, first, I had this thought crystallized in my mind, and then I got distracted with this debugging stuff. Sorry, one sec. Careful. Hope you're all wearing a mask. I don't want to give you COVID through my microphone. Okay, so why do I think this is the path forward first, even if we end up resurrecting stack-less coroutines? Because we need the I/O interface. Either way, we need it. We need applications to be able to control their I/O, and we need packages to be able to participate correctly. So, even if we resurrect stackless coroutines, we still need an interface. Okay, so that's point number 1. We need an interface. So, point number 2 is we can implement the interface in userland. There's an example right here, and I'm showing you swapping out thread pull version with an event version. I could have even made a single threaded blocking version where it just runs the async code directly, and then await becomes a no-op. And so we can implement it in userland, then we should. And then it becomes a null hypothesis. And then we can weigh the trade-offs of resurrecting stackless coroutines as a language feature and seeing how it works with the interface. So that's my argument for why this is the path forward, no matter what happens to language syntax. Next, let's talk about cancellation. So, cancellation is the idea that you start running a async function and then you want to cancel it. You change your mind, you're not interested in the results. So as an example, here's how we might write some code. Let me just borrow this example here, but we're gonna make it fallible this time. So let's say this has an error now, and also this one has an error. So now we naively would try this, right? Now that's a problem. That's a foot gun, because if this one returns, then we never awaited this one, and it's basically a resource leak. That's no good. So what we then want to do would be something like error defer cancel. We don't know how cancel works, but we need to do it. So how this pretty much would need to work is we have to give it a cancel token in both cases. And then maybe it's just something like, if I mod 1000 equals 0, then or I don't know. Maybe we check every time. You get the point. Like, there'd be strategic points in this code where we would put in the logic to check. And then you have to make a user. It's a user concept how to cancel something. So something like this. And then I don't know. Maybe this one actually is down here for whatever reason. I don't know. Okay, we're never gonna get this to compile. This is just an example. And then we need to pass it. So maybe this is like a pointer. Something like this, okay? So then we're gonna have cancel token.cancel. Now the problem is we also still need this to await the first half. So maybe we have that. Maybe we have that as like a like a nice helper method that when you set the cancel flag, it also awaits a future. Future is defined here, by the way. So it also could be a method here. So maybe you pass it a cancel token. Actually, that's probably the move. So probably we have this. We have the future have a cancel, and then you have to pass the cancel token. Okay, so now we're safe. Now this try is correct, because if this one fails, then we end up canceling both of them, which is fine, because it's just a no-op if it's already done. So this basically works. And whether or not we had stackless coroutines as part of the language with async await keywords, we would basically need to have this logic. Now, and I think it's kind of the same either way, because in both cases, the user code has to be aware of the concept of canceling. You have to put the logic in here. You have to put it in your state. And that would just also be true if we were using stackless coroutines as keywords. So that's just kind of how canceling has to work. And it has to be the user code that decides where to do it. So like in reality, we probably wouldn't put it in a hot loop. We would actually check for cancellations between probably like, file system or timers or something like that. Or sure, if it's a massive CPU computation, maybe you do periodically check for cancellations. But this cancel function would basically have to set the flag and then do an await. so that this blocks until the resource is cleaned up, because it might be referencing resources that are in this thread, in this stack frame. So that's pretty much the same. That's how cancellation has to work either way. And I think this is pretty reasonable, actually. This is basically what you want if you set up something like this. That's just kind of how it has to work. Let's see. So let's answer this question, and then we'll move on to select. So to fill you in, I think you just got here. Zig is going to have a way where you can make a package be agnostic of the I/O strategy of an application. What I don't want is for there to be a bifurcated ecosystem where you have all these packages that work with with blocking I/O, and then you just have a different set of packages in the ecosystem where they work specifically with this one implementation of an event loop. Like they only work with libxev, for example. Example of this that I encountered was Codeberg. Sitting him. Where was this? I can't remember. Oh, there it is. Okay, yeah. So Sittingham made this library, this package, so where it has actually a dependency on libxev. But it's unfortunate, isn't it? Because if I'm going to use this package in my music player, I'm not using libxev, but I still want to use this no dependency client for Pulse Audio. So why do I have to use libxev? And I found out later that I just misunderstood. It's actually a lazy dependency, and it's only used in tests. So it's not an issue. But it still is an issue, isn't it? Because what if I do want to use libxev? What if I transition my music player to use that, and then now this library is getting in the way because it's doing blocking calls to the networking, to the sockets. So this just made me realize, I already kind of knew, but we really need these dependencies to be injected by the application, not be decided by the dependencies, because that's going to bifurcate the ecosystem. So anyway, my point is, we don't have a chance of having colorless async. We're going to have it one way or the other. The question is there going to be a language feature or not? The use case is going to be solved either way. Okay, so let me look through this for some more questions, and then we'll go on to select. Oh, Gimli found it right away. Thank you. For efficiency, the operation would register to the cancel token how it wants to shut down, instead of the operation having to pull a flag. Yeah, blah, blah, blah. Okay. That line of thinking is how Go routines eventually end up fully preemptive. Which line of thinking are you talking about? Because my line of thinking is that they're fully cooperative. They're not preemptive. So if you don't put a cancel point in, it's not going to be cancelable. Would combining different IO implementations on the same package work at all? I think you're saying could an application spawn multiple kinds of IO at the same time and have them work at the same time? And the answer is yes. In fact, I think I can just try that out right now. Let's try that out. So let's have some fun then. I'll spawn one. I'll just do them all in the same the same context here. So we're spawning both. I'm gonna call this one threaded and this one evented, and then we'll just do them all here. So then we'll do this one. Invented. All right, let's try that. Now this use case is pretty rare. Like you usually would do one or the other. But there are cases when it makes sense to do this. Yeah, so there you go. They both ran, they're both done, everything's fine. They just operated on their separate states. Make sense? Now I'm gonna undo all that. Doing. Okay. That seems like a lot of runtime for Zig though. So there's no runtime though. This is all standard library code that you can choose to use or not. So this is not code that goes into start. The start, this is the runtime code. This is literally the code that runs at runtime. And you can see it's pretty thin. It's just do something with unwind tables, grab the args or something, and then we basically just call into main as soon as possible. Oops. Do something with the environment, expand the stack if we have to, get ready for thread local storage. This is all basically just equivalent to what libc code does. Run the array constructors, and then we go into main. This is the runtime of Zig. It's pretty much equivalent to the C runtime. Maybe set up a segfault handler, and finally we're here. We just call main. We do something special if you have error, if you return an error. This is a runtime. This is not a runtime. This is a event loop that you can choose to initialize if you want to, or not. And likewise, this is not a runtime. This is an interface. And if you use this interface, you're not tied to any particular runtime. You are going to get what the application chooses to give you. And the application could choose to just give you something simple like lower read and write directly to read and write, and then it would be pretty much the same. And the nice thing about this proposal with restricted function types too is that the function pointers of the interface that are never I was going to say they're never called will never be lowered, but I don't think that's actually true. I think you would still get the danger of there being a runtime would basically be the danger that there could be functions here that are not called that still have implementations. There's ways to address that problem though. For example, you can simply like turn those functions off if you don't need them. But let's be clear, it's not a runtime. There's no runtime here. It's just the application choosing how it wants to do I/O, and it can write that code itself if it wants. And in a language like Go writes that code. You don't have a choice. In this one, even if you use the I/O interface, you still have a choice on how you could write the implementations, and you're going to decide how your dependencies are going to do I/O. So that's different than a runtime. Grand Central Dispatch, yeah, I know about that. Can you show cancellation but with async function that awaits itself? No. How about I await itself? If we're doing inspo, libm prompt, decided to give Zig a try after voicing his thoughts. Okay, let's get going to the bottom here. Do you see my point about the I/O interface being a good thing in the embedded world? To summarize, the I/O interface is a good approach and it's already been used. Okay, that's good. I reckon that the restricted function pointer types proposal would allow us to make a comp time only implementation of a vtable interface. And it would be okay for the vtable implementation to actually be comp time only functions, i.e. they compile error at runtime? What? Well, we'll have to go into this later. I don't think I'm going to try and understand this on the stream, but it sounds like Matthew's got some interesting ideas here. Question was about async functions that await on other async functions. Okay. Well, we're going to get into that on the second half of the stream. Waiting on another async function is just a function call. That's the nice thing about this. You don't have to do any special thing. You just call stuff. You just call functions and it works correctly. That's the whole point. Okay, so let's do one more, talk about one more concept, and then I'm going to transition into trying to do some work. We're going to try to... I'm going to learn lib-io-ring because... Or not lib-io-ring. I'm going to learn about using io-ring because I've never used it before, but I like the idea behind it a lot, and I want to try to integrate it with this. Maybe just basic like open a file, close a file. We'll start there, and then we'll start to build up this example to actually do I/O at the same time, and it'll be very interesting. FYI, io-ring is banned in most cloud environments. Well, that is a crime. That is a crying shame. But that's why you have this, so that you can... That's why you have the interface, so you can swap it out seamlessly with a different one, such as epoll or whatever else. But I think that's ridiculous. io-ring is great. They shouldn't turn it off. They should fix the bugs and keep it on. That's my opinion. Does this still bifurcate libraries into those that use async and those that don't? No, that's the point. The whole point is that if you write, there's two use cases that you want to be able to do, and you're in your reusable code that you're sharing with the world and with yourself. Okay, one is you don't have any concurrency to express. You just want to do your logic from straight down, top to bottom, without thinking about it. And you want that to play nicely with applications that choose to use an event loop. So for example, I have a JPEG image loader. I just want to do freads. I want to read my file a bunch of times and create my structs in memory and not worry about async or this or that. I don't have any async. I don't have any await. I don't have any of this or that. I'm just doing read. That's it, right? That's use case number 1. So the point of that is that will now go through the IO interface. You use IO interface.read for all that stuff. No async, no await. You're just doing reads. And the point is that will then be, because the event loop implements the IO interface, the event loop chooses how those reads are lowered. That means that it can make those reads non-blocking. And because it can use green threads, it can turn those reads into non-blocking reads that participate correctly in the event loop. But to the JPEG package, it's the same code. You just got to use the IO interface. That's all you got to do. That's use case number 1. Use case number 2 is you do have concurrency to express. You are able to say, like, I want to read from this region of the file. I also want to read from that region of the file. Maybe also, what other kinds of IO do we want to do? I don't know. It doesn't matter. Point is, you do have concurrency to express. You express it with async and await. IO.async, IO.await. And the point is that even if the application doesn't have an event loop, it just wants those operations to be done in a single thread sequentially. It just has to provide a single threaded sequential eager evaluation implementation of IO, just a trivial, simple, reads are reads, writes are writes, no delays or anything, and it still works. So the async, you can express the concurrency in the package. The fact that if it was possible, you could do these things at the same time, but they can still be lowered sequentially. So it works in both ways. So that's the whole point. I think I was answering. It's been the point the whole time, even with the previous implementation. Does it bifurcate libraries into those that do and those that don't? No, it doesn't, and that's the point. Does that make sense? That's been the point the whole time, even with the previous implementation. I think I have a hot take on this cloud stuff. It's not even hot. It's more like lukewarm. But has everyone noticed that if you work for a company, everyone is obsessed with moving to the cloud. They're like, oh, we got to move to the cloud. We got to move to the cloud, right? But like, why? Is it cheaper to move to the cloud? No, it's not. Is it less maintenance to move to the cloud? Maybe. Is it cheaper to move to the cloud even if you count the salaries that you're paying the people to maintain your data center or whatever computers you run? No, it's cheaper to pay people to maintain your own computers. It's more expensive to go to the cloud. Why does everyone think it's a good idea to go to the cloud? Because everyone does think this. Like, I remember being in at every company I was at, everyone's like, we got to go to the cloud. We got to go to the cloud. I think that what's happening is that it's so simple. If you just think about it, if you think about it clearly, these companies that have massive budgets, Google, Amazon, Microsoft. Are there any more cloud providers? It's like 3, right? They have these massive advertising budgets, and they own all these assets. They want you to rent their computers. They want to be your digital landlords because they just get free money. It's literally free money. And so they want you, your company, to sell your assets to them. Or just destroy your assets. Doesn't matter. Same thing. And then instead of basically living in your house for free, Now you're paying rent every month, but it's the digital version, right? Like they just want to be your landlord of your digital assets. It's so simple. It's such a simple concept, but there's so much money to be made that they're willing to spend these like enormous marketing budgets just to get people to believe in the industry that moving to the cloud is a good idea. Like they'll just spend like ungodly amounts of money on hosting these conferences, like just tech conferences. As long as just like people are going to tech conferences around the world and like half the talks are about cloud stuff, then everyone just thinks like it's like become this cultural thing where we all think like, gotta go to the cloud. But it's like the emperor has no clothes on. You know what I mean? Like it's not better to go to the cloud. It's worse, actually. It's subjectively worse. And the more people that go to the cloud, the worse it's going to get because it's going to become more like a monopoly. It's like everyone not on the cloud are the ones keeping the prices down of the cloud. So just, I don't know, next time the culture is telling you got to go to the cloud, maybe question it a little bit. That's all I'm saying. Do I think Jeff Bezos will own and operate every computer in the world? I mean, I think he'll try. Why not? I mean, my fucking dishwasher takes like 3 minutes to boot. What is it doing? What could it possibly be doing? Oh, man. All right, where were we? I totally lost my train of thought. But yeah, it pisses me so much off that if they have all that money to get people to go to the cloud, then just fucking fix IOU ring. Like, come on. Like, I don't think it's a conspiracy to not fix IOU ring, but the incentives are wrong, aren't they? Right? Because if you're using IOU ring, you're going to use the cloud more efficiently. So you're going to incur fewer costs. So they literally lose money if they fix IOU ring. So don't let them turn it off. I'm sure it's just it's mainly probably just a bottleneck of developer effort, but like, just fucking pay someone to fix it, right? They have so much money. Why are they not paying someone to fix it? Okay, so anyway, getting back to concurrency and reusability and stuff. This was an important question, so I want to make sure I answered it correctly. Does this mean that if I do have concurrency to express, I cannot rely on that concurrency existing, or more that there can't be a dependency on the test run currently? That is correct. So when you use the IO async abstractions, you are not guaranteed that they'll be running in parallel. You're expressing that they can be run in parallel, but not that they must. Now, however, you can always require things about your parameters. So, for example, I could do this. I could say requires a IO implementation that supports running like timers, something like that, or supports running at least two things at once. You can just make up rules, right? And then if you try to call this function with an IO that doesn't support that, then you can detect that, or you can fail, or it can just be broken. So it's the same thing as with an allocator. Like when we take an allocator, you could say like requires an arena allocator because it does not try to free anything. You see what I mean? It's the same kind of deal. Does that make sense? Even threads may not be parallel. That's interesting. Okay, so where are we going now? I think one more thing. Let's talk about select, and then let's try to actually write some code, because we're already about an hour and a half in, and I haven't written any code yet. Let me answer this question though. This is an important one. So, what's the difference between the IO object and the event loop? So, one of these is an interface, and one of them is an implementation of the interface. So, just like you have a implementation of an allocator, and then you use that to get the interface for an allocator, you have the implementation of IO, and then you use that to get the interface for it. You have an implementation of IO, and then you use that to get the interface for it. Does that make sense? So you have to fulfill the interface in an implementation, and there can be more than one implementation, just like allocator. It's just an interface. An interface is a computer science concept in pretty much every language. The key insight is just that you can do some kinds of asynchronous programming in user land. So use cases outside of IO would still use an interface called IO. No. It would all be IO, but async and await are counted as IO. Because they do have to do with IO, because IO is having to do with scheduling, and the point of async await is scheduling. So the reason for this abstraction is to abstract over the difference between blocking and non-blocking. That has to do with scheduling. Async and await has to do with scheduling. So it's all part of IO. Will allocator be part of IO? No. Why would allocator be part of IO? Guys, come on. Let me have some more. Will I be part of IO? Oh my god. Time is IO. Yes, time is IO. Definitely. Yes. Sleep is IO. Anything that can block or not block. Okay. Wow, everyone's just coming in. Any thought of doing a TLS interface, thread local storage, or transport layer security? If you're talking about transport layer security, I've got that solved in a branch. I'm redoing. I'm already halfway done redoing reader and writer to also be an interface. That ties into this too. And TLS is no longer generic in that branch. A lot of things are no longer generic in that branch, and it's a pretty good improvement. Yeah. I'll go over that later. I think I'll probably not try to do that on this stream, but there'll be a pretty interesting demo there too, but I want to get that demo working before I show off that work. Oh, I didn't post my example usage in the branch. Sorry. Let's get some. How do I get some text to you guys? Let's delete that. Does seal bin still work? Seal bin is shutting down soon forever. Oh, that's too bad. I guess people finally started abusing it. Well, change these to a T's, and I think you got yourself your oh wait, isn't there a way to send links to Bork or something like that? Oh, it's the other way around. Oh, Bork send. There we go. Will I be reopening any of those popular issues I bulk closed? Probably not. I don't know which one you're talking about. Okay, so let's go over select and then try to write some code. So, next example. So the idea behind select, if it was a language feature, I think it's a language feature in Go. The idea is that it's kind of like switch, except the prongs are like future. I don't know. Is this like the result maybe? And then is there an else? I don't know. Probably not. So, and then we would, yeah. If it was a language feature, it'd be something like this. Maybe I do the example up here. And then basically you just find out which one wins. So one of these gets activated, whichever one finishes first, and then the select returns. And the other ones are not awaited. You would need to like cancel them or await them. Comp time interfaces? Nah, that's not getting reopened. It's implemented as a macro for async Rust. Oh, that's interesting. The else prong is called default. What does the default do? In Go. It works on channels? Okay. There was a lot of questions about how to implement this in the language. Because with the way that async functions work before, futures was a specific, it was a language type, a type provided by the language instead of being defined by the IO interface as it is here. If selecting would block, default is selected. Okay, I see. So then that makes sense to me. So then you just don't put the default on there if you want to wait. Gotcha. Okay, so basically there was just too many design problems to solve with select in the language. There's an issue you can go look at if you want to just see all the problems. It's just a mess. So I just want to point out that with the whole thing implemented in userland, it just becomes a lot easier to solve because, I mean, we can just have a bunch of forms of select, you know, like we can have one where it's not going to have the nice syntax, but we could have one where it's like maybe you give an enum and then that becomes like the fields, something like this. And then that turns into, that gives you like something you can switch on. You get where I'm going with this. So this might be what kind of a userland one looks like. We're repeating a lot of stuff, so that's annoying. But it could work. And the nice thing is that there could just be a bunch of forms of this. So maybe we want one where it's actually like a slice, and now we're actually passing things in like this. Is this a bival object? I suppose. I don't know. Doesn't matter. For the purposes of it doesn't matter too much. And then we get like the index of the one that triggered something like this. My point is, all of these things, we're gonna have like language implications, and then changing the language would be a pain in the ass, and then we might need to introduce all these types and everything. Whereas doing it in userland, yeah, it's gonna be a little messy, but we can just have like 2 or 3 different forms of it. You know what I mean? It can just be a lot more explicit. We can have errors. We can have it like have possible errors. It's just so much more flexible when you don't have to worry about polluting the language namespace with a bunch of features that are only needed for this one weird thing. Whereas if we can do this in the interface, then we're looking at, we just have a lot more tools in our bag that are acceptable to use, if that makes sense. So I think that's a pretty compelling reason to explore implementing select and related features in userland instead of as syntax. Okay, so we went over cancellation, we went over select, we went over the main ideas here. I showed you the little demo as it exists. Let's actually try to improve it now. So I haven't never used IOUring before. I want to learn. I want to start adding IOUring. I want to just do some simple just some simple IO. And let's try to get it working. Let's try to integrate it with the existing thing. Okay? So Jim wants to see the thing again. I gave 2 examples. So here's one example of an implementation on a slice. Here's one example of an implementation that uses some type trickery. My point is that there's different things we can do. We can get creative with it, and the grab bag of tools that we have access to is large. Whereas when it's a language feature, it's very constrained what you can do. You know, you don't want to make too many language features. Okay, so let's write some code. I'm going to have a 10-minute potty break, and just reset my brain and relax my vocal cords for a minute, and then I'll come back and we'll do the second half of the stream, which will be writing code. And Rocco Rager, sorry. If you're still around to help me get started on IOUring, that would be really sweet, since you just have it fresh in your mind and I don't. But no pressure if you're busy. I think it'll be fun to try to get that off the ground. Okay, so I'll set a 10-minute timer. Everyone go potty, and we'll come back and write some code, okay? And then when we come back, Loris is going to give us a Zen story. All right, Loris? Good night, Jens. Awesome. Okay. All right, how do I set breaks? Bork. Oh, here we go. All right, 10-minute break starts. See you all in a little bit, and we'll do part 2. did I miss the time again? Oh. Well, I not only made tea, but I ate some bread too. Okay. All right, how's everyone doing? You ready for the coding part of the stream? I'd like to answer this question. Well, this is going to come up when we start to implement this code. So the question is, are these functions started immediately? It's a good question because I'm pretty sure in Rust that is not the case. So the way that this works is that you make that decision in the implementation. So, for example, in the thread pool implementation of async, here you can see we allocate this closure. If that fails, we do in fact just run it immediately. So that's kind of like an allocation failure handling strategy. But if that succeeds, then we actually start running it immediately on another thread. Okay, and then you can see in the other implementation, here we are. This is the fibers one, or the green threads one. Again, if we fail to allocate or recycle a fiber, then, or a green thread, then do it immediately. So it's kind of like a, oh hey Matt, it's kind of like a fallback strategy to do it immediately. But if that succeeds, then we actually just schedule it to run immediately, and so it will get run immediately. So answer being, it's a implementation choice. Implementation defined how it works, whether it goes immediately or not. Personally, I like making it go immediately, because why not? If you can do it, then do it. Let's look at the cone, or whatever it's called. That didn't work. Okay, here we are. Oh boy, this better be good. let me get my podcast voice on. Hold on. All right, we'll do this cone and then we'll start coding. In the small town of I.O. one day, a rich merchant was strolling down the town's main commercial street. The merchant was wearing colorful clothes made of the finest silks and wore big, heavy rings on almost all his fingers, symbolizing his success as a businessman. As he walked down the street, his gaze would stop to thoroughly inspect each shop he passed by, barely hiding his disgust at the rundown state of the average business in the small town of I.O. Normally, he would have only one reason to inspect shops, not to buy from them, but rather to buy them. He would only very rarely buy at a shop, as that was a job for his servants. But today was a special day, and he was looking for a very specific shop, because he wanted to buy a very specific item. As he reached the average value of when a linear search into a space succeeds, he found what he was looking for, a tea shop. Not only smaller than the average shop in the already small town of I.O., but also more run down. Despite that, a big smile could be seen on the merchant's face as he entered the shop. "Welcome to my humble tea shop," said the owner, a small and run-down old man, just as small, old and run-down like his shop. "Grab a seat and order some tea. We have all kinds." "Thank you, kind old man," said the merchant. "You might not recognize me, but I used to come to your shop very often when I was young and poor. At some point, I moved to the big city and made a fortune. I ate the finest meals and drank the finest teas the city had to offer, but all that time I longed for a sip of your tea, for I remember it being the most sublime tea I ever tasted." Your kind words warm my heart, but I'm just a humble tea shop owner in a small town, and I doubt my tea can really be any better than the finest teas of the big city. But the merchant didn't want to hear it. Nonsense, my friend. Brew me some jasmine tea like you used to. A little over 2 minutes and a half later, the merchant was presented with a fresh cup of tea. Are we supposed to watch this right now?
Gonna be roughly how long does it take to heat water in the microwave?
I put it there for 2 minutes and a half. But here's my trick. I also put the bag in there.
No, you don't.
Yes, I do.
No, you're saying that to troll me. You did not put your bag in the microwave.
I do. I do. That's why it's a time saver, because you basically that becomes the infusion time.
Oh my god.
Oh my god, this has to be part of the stream.
Finally, you have no idea how long I've awaited this moment, said the merchant as he took the first sip. Instantly, almost as if a fire burst inside the man, his eyes lit up, his lips tensed, his nostrils widened, and his ears perked up, and then nothing. The merchant moved his tongue around in his mouth a bit, trying to recapture the subtle, fleeting flavor of the ultimate jasmine tea he was sure he had just tasted. Or maybe he thought he had just tasted. He took a second sip, and that's when he realized that he hadn't tasted anything special, but rather he just hoped to have tasted something that just wasn't there. Did you change anything from when you made this tea years ago? Nothing at all. Same water, from the same spring since I opened the shop. And you collect it the same way? Same exact rusty bucket I always used, which I scrubbed once a month like I always did. What about the tea? Do you source it from a different producer? Jasmine tea comes from my cousin's fields like it always did. He's now as old as I am, but nothing else has changed. He still brings the tea in the same rusty bucket he always used, and which he cleans once a month. Are you sure you really didn't change anything? Are you sure you didn't use inline assembly to swap out the stack and change the program counter to continue executing other code without me noticing? Nothing has changed except for one thing. Aha, there it is. You finally remembered. Spit it out, you senile old man. What is it that you changed that made the tea taste worse? I changed nothing. The only thing here that changed is you. Have you considered that this might be the reason why my tea doesn't taste as good anymore? As he heard this, the merchant did actually taste the flavor he was seeking, but only for the most brief of moments. Wow. That was sublime. Thank you, Loris. Oh boy. Okay. Let us continue. Oh, I fixed a bug, didn't I? All right, let's put that in a place. Okay, now, thanks for the people who just joined us. We just spent the first half of the stream talking about a new way of doing async await. See you, Jim. Thanks for stopping by. We took a break, and now we're going to further explore this idea by adding more I/O to the I/O interface, such as file system stuff, and making it interact with async await so that we can see an example of code that can do seemingly blocking operations, but then also participate correctly in the event loop and so on. So let's start with adding a function to the interface. Then we will implement it in the thread pool implementation, which will be simpler, and we'll make sure it works. We'll come up with a nice little test. we'll call that a checkpoint. We'll make a commit. Then we'll try to implement it also in the event loop implementation, which will be more involved and will require learning IOU ring. It's an ambitious goal. We're already 2 hours in, but I've been programming for I don't know how many years. What's 36 minus 12? 24 years. So maybe I can pull it off in a couple hours before I get too hungry. All right. So let's start with our example code. So we're going to start with thread pool implementation. We're going to turn this one off for now. This is our silly example. Fine. Let's keep that there. Let's also do something else that has to do with the file system. So what we'll do is we'll have maybe we'll open a file, and we'll do maybe like I don't know, rot13 or something, and then save it. Does that sound good? So let's see what that would look like, and we'll do that at the same time as the other stuff. Okay, so we're gonna need to pass in the IO, of course. By the way, I was already thinking that probably this should change so that it looks more like thread pool spawning. Sorry, yeah, thread spawning. With like just passing the args that you want instead of a struct. So I'll probably do that, but let's just keep it for now. So what's our logic then? We're going to, first of all, we can have an error. I don't know why I did that. We'll do file equals. Okay, now we need to open a file. So let's come up with a interface for that. I guess we'll just start with opening and closing a file, okay? So for reference, it's basically this function that we need to implement. So open file. Okay, now we'll have a standard fs.dir. That's the same. That's just an OS resource. If we really have to, we can wrap resources in the IO namespace, but if we don't have to, that's nice. So let's not assume we're going to need to do that. Okay, now open flags might need to change because if, for example, non-blocking is in there, then that's not quite what we want. Yeah, see, non-blocking. So not quite what we want. We have to define our own open flags then. So let's keep some of them though. What's open mode? Is that a fs.file? Okay, read only. Where was I? There we are. Let's just leave it as open mode for now. Come back to that. We have bigger fish to fry than those details. Yeah, it might be nice to alias some of this stuff, but oh, oops. This is the one that we're working on. Okay, so then we have this is the same. And unfortunately, that's going to have to go down here. That's fine. Could put it up here, but I think it's nicer like that. Okay, so we have open flags there. And I think that's really all there is to it. So let's try to implement this function now. And we'll do close file as well. That's just a no op or one of these, and then void. Thank you, Lee Cannon. Yeah, I got him wrong. Okay, so we've added these things to the interface. So now it's going to fail to compile because we didn't satisfy the interface. In the thread pool thing. Perfect, that's what we wanted. So now let's go satisfy the interface. Ah. What am I doing? There we go. Okay. I messed something up. So key difference between these signatures as they exist in the interface and elsewhere is that in the interface, they have access to the user data. So pretty much every function in the vtable is going to take this and have access to whatever the thing is. If I'm using no LVM, I should totally demo how cool Zig is by using F incremental. Oh, unfortunately, I'm not using Zig build, so I can't do that. I don't have a file watcher. I guess I should have set that up though, huh? Yeah, let me just try to set a good example for people. Okay, so then instead of this test.zig file here, I will I'll just make like a temp directory. Let's do async demo maybe. Okay, let's get rid of root zig. Oh. Well, this is my editing of the standard library. Let's just go ahead and write this to how do I switch my buffer to be editing that file? I think I do E, right? Okay. And then that... Wait, what? Oh, this is fine. Okay, yeah, and then... Now I do in here... I can do zig... build watch incremental. I need to set no LVM, right? No lib. I don't want a static library. What is going on here? So much stuff. I don't need run either. Okay. Wait, I also need well, the code gen's broken, isn't it? So I got to do that thing where we set up No cogen should work fine. Are you saying no cogen should work fine, or no, cogen should work fine? Okay, well, let's just try it. Okay, we need the first one to compile successfully. Oh, that's the build script. Okay, so we got the build script going. Okay, so here's the workflow that we were trying to get. So now if I save, just updates right away. That's pretty nice. Hapjack says, I've been using the incremental compilation that you demoed last week to check compiler errors. It's so damn fast. Turned off the 50 ms delay as well and used no LVM2. Then I use enter as a file watcher to run the compiled program. Very nice. Okay, yeah. Why do you need this one? Enter. Oh, I think I know why. Because if you make a run step, we don't really have that integrated really well with like rerunning it. Is that right? I guess like the ideal would be you set up like a unit tests and then you just run the unit tests over and over every time you save. I think that's kind of like the end game here. I haven't tried that myself yet. But that's probably what we'll try to get to, you know? And yeah. What are you using to get the errors into the location list? Oh, this is... You're talking about this? So just so you know, this errors are not the same as these. These ones are instant and they're on save. That's just the Vim extension. So there's a class of errors that you can get. It's the same errors that you get if you run... zig ast check. So for example, if I pass in the same file name, I'll get the same errors right there. This command is very fast. It's always this fast on every file. And it's a limited set of errors. But it doesn't need any more context. It's based on the file only. So yeah, I highly recommend to get your editor set up so that it runs this on save. You can also do format check. So then it'll reformat the file and print errors if it has errors. I demoed something wrong. Sorry about that. Yeah, I meant to do that. So you can also do this, which will reformat your file and check it. So I have this on save actually. So that's a good way to go. Okay, so back to this. What are we doing? Oh, wait. No. Open file. Okay, so this is the thread pool implementation. So this is going to be pretty straightforward. We're not going to do anything fancy. We're actually just going to directly do the operation. So it's pretty much just going to forward it directly to the file system in this case. It's kind of a warm up, and then we'll do the actually like interesting hard thing. So we'll do standard. Actually, we just do dir.open file subpath, and then we can set the flags, and that's just going to be mode. And then we do. No, that's fine. That's all we're doing here. Okay. And we just return that. So this is pretty trivial. Like this, in this, This is kind of like your null hypothesis implementation. It's just going to forward the request directly to the file system. We don't even need to access the thread pool at all. Just do it, right? And then same thing for close. We don't need access to anything. And then we have the file, and then we just call file close, and it's blocking, and that's expected. Okay, so I think that's all we need to do. Now let's go back to main and continue writing this code. There we go. So let's do open file, example.text, and then obviously example.text is going to be, let me just get rid of these other things. This is obviously going to be our cone that we were just looking at. There we go. We need a directory. Probably, we can worry about CWD later. It's not, at least on this computer, it's just a number. So we don't need to worry about that for now. I don't think, yeah, anyway, besides the point, let's not get distracted. Then you can use defer like normal. Although we don't want to do f.close, we want to do io.close file. So there's that. Now that's obviously a foot gun. F.close would be a very natural thing to do. So trying to encourage use of the higher level IO abstraction is going to be a challenge. That's obvious. But let's try to make it happen. So let's try it out. Okay, why doesn't it compile? Local variable is never mutated. Oh. Okay. Main 62, missing IO. Okay. IO not accessible from inner function. S.io. I want to use local variable. Right, let's do something with that. So we keep this code here just for fun, and then we're gonna rot 13.await. And we can try that. I think we should start caring about cancel soon, but let's just leave that for now because that's the first thing that can. We've already awaited the other stuff, so we're okay on that front. So let's just do this. All right, how we doing? No field or member function named open file in IO. Looks like there's one there. Oh, right. Okay, so this is the interface, but this is type erased, and there's type safe wrappers around everything. For these, well, yeah, see, it's type erased because of this. So what we want to do is wrap them. Is that what we're calling this thing? Yeah. And actually, we want to do this IO. vtable. And then same thing for close file. Yeah, this would be a good solution. Yeah, there's definitely solutions to it. It's just going to be a little painful in the transition. But you know what? It's okay, because basically we can use these breakings as ways to encourage people to migrate to the IO abstraction. So first we need to make it good. We don't want to tell people to upgrade to something that sucks. And then once it's good, and we know it's good, and we've tried it, and we've battle tested it, then we can start breaking people's code and saying, sorry, you need to use the IO interface. I promise it's good. It's gonna make your code more useful to yourself and to other people. And then we'll have a good justification for that. Okay, so then we need a file here. Let's just void. Okay, now what? Missing struct field, open file. Okay, so now this is the part where we populate the interface. Sorry, not there. Here. Okay, nice. Very nice. Wow, Matthew. Great suggestion. Does it work? Probably. It wouldn't do anything. Okay, great. Works. We don't know if the backend... Oh, because I didn't run it. Well, yeah, I ran it now. Run strace. I'll always oblige that. One thing to keep in mind is that we're using the debug allocator. So you're going to see tracing for stack traces. So I'll switch allocators for you so you can enjoy that. So there's a lot of noise between just... Well, I have a lot of cores. I think it's 16. Yeah. Oh, wait, 32. I have 32 logical cores. How did I not know that off the top of my head? So you're going to see like 32... what did I just do? Oh, I closed it on accident. Sorry. So you're going to see 32 logical cores being spawned. And then finally, you're going to see some action. So there's that one. There's the open. There's the write. Would be more interesting to maybe... Well, I don't know. Oh, you want to see E file? What does this do? Oh, that's nice. Okay, well, there you go. So open the file. I don't see close the file though. Do we? Did we not close the file? Did I miss something? Oh, it closed. I think that... Oh, it's this calls with path. Okay. Got it. Right. Anyway, so let's go back to the debug allocator because it's useful. Okay, that was pretty simple. That was a good warm-up. Let's keep working on it with the simple thread pool one until we have our usage code being more interesting. So let's actually do the rot13 thing here, right? So I'm thinking next we're going to read the file. So yeah, we'll do read and then we'll do rot13 and we'll do write and then we'll be done. And then we'll try to do it with the event loop. Let's see what Gabby DD has to say here. I have a lot of success with using incremental while experimenting with text rendering. At one point I thought incremental was messing something up, but I was just trying to read a type of font file I didn't support. Nice. Were you doing it with you're doing it with CodeGen enabled? Oh wow, okay. Cool. Yeah, we'll try to get that be more stable, but I can't recommend turning that on for everyone yet because it's it's not quite robust. I've seen that linker code and it's not up to the task, unfortunately. But hey, if it works for you, I'm not gonna stop you. Debug auto checks for memory leaks. Would IO debug handles leaks? Detect leaks? Yeah, you could make an implementation that would do that. That's maybe another benefit of this strategy. I think when you really think about it, having all IO as a parameter, it really gives you a lot of benefits, doesn't it? It's like the more you think about it, the more you're like, oh yeah, that's definitely the way to go. Okay, so let's write out some more example code here, and then we'll do the simple implementation, and we'll try to do the event loop one. So next up, people have been doing this in functional languages forever, right? But what would be the thing I would bring to the table here is that I would convince a bunch of systems programmers to do it. You see, that's the new thing here. Just get everybody to eat their broccoli. You know what I mean? Well, great. I'm happy to see so many people have been benefiting from incremental. Yeah. That's great. Yeah, and we'll continue to make that work better. So the next release, we hopefully can just tell everyone, yeah, go ahead and turn on CodeGen and it'll work. Yeah, I do think it's a lot easier than Haskell because you don't have to do monad stuff. Like, it's just an interface. You still get to write imperative code. You just have to do your imperative code on a parameter instead of accessing a global. I mean, it's more like not having global state, really, than it's more like avoiding global state than some kind of monad thing, I feel like. Like, I think in Haskell, like, the monad thing is like, instead of doing your IO directly, you have to kind of like construct a I want to do IO request and then return that from your function. Like, that's way more complicated. We're doing the IO here for sure. We're just doing it from we're just operating on an interface instead of globally. That's all. Okay, so let me do the thing. I keep talking. Okay, so we're gonna need read. Well, let's go ahead and dream big. You know, I want my read all. So, still gonna have buffers like normal. Let's just give it this much. I'm gonna resist the urge to try and tie this into my work in progress buffered reader branch. Resist the urge. Resist it. Okay, urge resisted. Yeah. And then we get some short read. All right, I'm not gonna worry about short reads for now. Okay, now let's do rot 13. in a minute. Okay, I think that's what we want. It's like ASCII rot 13. All right, next, we want to write it. So we got to open another file. Okay, this will be interesting because here's what we're going to do. First, we're going to write this out in a kind of like straightforward manner, and then we can maybe introduce async await to these function calls, and that'll be like a separate interesting thing to do, because we can say async close the file, right? And also async, well, okay, another way, we can do async open the input, async open the output, and then we can also do async, we can try to close the files together as well. So there's some stuff we can try and do at the same time, and let's try and do that later, because I think I might want to change the async signature to look more like thread spawning. But one thing at a time. We gotta eat this elephant one fork at a time, one spoonful at a time. I don't think I want to eat elephants though. I think elephants would be better to just be alive and happy. Why am I talking about this? Focus. What am I doing? Okay, open the output file. So this is going to be create file. Where would be the best place to ask about implementing features? Not interested in proposals, sorry. If you're trying to implement a accepted proposal or a contributor friendly issue or solve a bug, I can advise you there, but we're not interested in proposals from anyone. If you want to make a proposal, you gotta convince a core team member to file it on your behalf, but don't harass the core team members. Sorry, too many ideas out there, too small of a team to review them all. Maybe one day I'll do PeerTube or something, but for now it's just it's ethereal. The VOD's on Twitch for however long. Twitch lets it stay there and then it disappears. Super user, you missed the first half. First half we went into the motivations behind this. Basically, it's code reusability. Somebody started archiving my streams on YouTube. Okay, I guess that's fine. By the way, I don't know if you saw, but I added a talk section to my website right here. There's some talks on here that are not hosted on YouTube, so you might have not seen those. Like, for example, this one. Why is the newest at the bottom? I don't know. It just made sense in my head. Like, it's kind of like a playlist, you know? Like, you start here and you go down. I don't know. Someone else pointed that out too, and then I went to go fix it, and then I didn't want to. Okay, so the output file, we need a create file function. So that's going to be create flags. You know what? These flags can work verbatim, I think, actually. Okay, besides the point though. So do create file. Path flags, yeah, okay. We'll do s.io.write. Actually, we're going to do write all. There we go, baby. Excuse me. Somebody spotted the Easter egg. You must be in light mode. But if you go to my homepage after dark, GoDaddy comes out. Mm. Okay, so we have write all here. We need a file, out file. Contents. We don't need this anymore. Okay, so that's the whole example. Let's make this work with thread pool implementation, and then let's try to learn how to IO URINGWorks. Should be fun. Let's follow the red brick road. So we need read. Let's do read. It's an important function, you know, read. It's a good one. Read. Let's pretty much just rip it from here. But we need to add the non-globalifier in there. Yep, of course. Yep, of course. Okay. Now we need to give it the same treatment as down here. I don't know why I didn't just start like this. This would have been the move here. There we go. And then change this one. And then just do this. Okay. Now what? Read error. Now what? Missing read. We got to implement it. One thing that's getting a little weird is that this is the thread pool implementation, and now it's getting like IO into it. So I probably want to put this in a different file that is more encapsulated, but I'm not going to worry about that because I'm in a branch. We're on a stream. We're going to not try to solve the wrong problem. You know what I mean? Got to focus on the yak that we're currently shaving. One yak at a time. Okay, now I need read. Okay, then this is the simple, just do it. Do a file.read. Easy, nothing to do. Yeah, that looks wrong. You need the file. How are you gonna read with no file? No field member named create file in IO. Okay, great. So now create file is a new one. How do we create a file? I also decided that open flags can just be open flags. Yeah. Create flags is good. Open error, same error. Okay, yeah. These two functions are basically the same. One thing that one thing I probably would do is yeah. We would make our own open flags here because these are the same function according to the operating system. They're just different. Like the fact that we have create and open are just because the API is nicer that way. But the whole point of this interface is that it's kind of like the it's not a bottleneck. It's the type erased kind of like efficient semantical way of describing the operations. So, and then down here, this is where we put kind of like the API helpers. Like, you know, here's the part where it makes async kind of nicer, that sort of thing. So it's actually better to do open file. Yeah, and then have our own open flags. Yeah. And then create file is instead implemented down here, just as a different way to call open file. So a different set of flags. You're not quite there yet, but there's two things that annoy me about the IO ring API. Maybe I'll PR it at some point. Functions are snake case and not many have a defined error type, even when the errors are finite. Ah, yeah. Yeah, I think the person who contributed that did it based on lib IO ring, and they kind of did a direct port. So that's kind of what we got. You're very welcome to send patches to that, especially if it comes from actually like using it, trying it out, you know. I'm sure I will have similar opinions once I actually use the API. I've been relying on contributors for the IO ring stuff in the standard library. And yeah, see the using namespace usage there was also because, you know, basically pound include in C is using namespace. Sorry, I hit the mic. So it's just easier to do a direct port with that feature. It's well commented. It says implementation copied from Living. Oh, there you go. Yeah, that makes sense. Okay, so now we need to convert these flags over. No big deal. But we need to decide what the flags are. So this is the part where we get maybe I'm just trying to do something too silly. I think it's fine. Okay, so what's open mode? Open mode is that one. So we have read only, write only, and read write. Oh, I see. Read. Let's just keep mode. Truncate. I think I'm overthinking this. I'm sorry. But we're gonna roll with it. Wait, what is this? Lock. Oh, okay. All right, I think we're gonna need FS. Okay, we got past AST check. Okay, these are still wrong though. There. Okay, so open flags. Oh man. I made this bed and now I'm gonna sleep in it. Open mode equals flags dot mode. Lock non-blocking allow CDD. So these ones can be passed directly. Okay, and then the other ones are truncate, false, exclusive. What is exclusive again? Ensures that the open call creates the file. It means it has to be created. It's already false. Mode doesn't matter. Yeah. Okay, that's fine. Bye. I know it's a weird time zone for everyone. Okay, now create flags are going to be different. So we have read open mode equals if flags dot read write else write only. Those can be the same. Lock non-blocking. Mode equals mode truncate equals flags dot truncate. Okay, I think we're fine. Front end. Okay, now this function has to be able to do open or create depending on what we end up doing. So this is where we kind of reach down in and oh, did I miss something? Thank you. So this is where we would reach down in and, you know, massage over the difference between creating an opening. So let's go ahead and do that. I should have just made them 2 functions for the purposes of the stream. I mean, I'm not wrong trying to combine them like this, but yeah. Whatever. Basically, this logic should go... Well, I don't know. It's hard to argue where that logic should go. Let's just start with this. Let's start with POSIX. Flags. I don't really want to copy paste this code into here. Okay. I'm on the right track here, but I'm gonna back out and simplify this, okay? Sorry. Turned out I didn't want to sleep in my bed. I'm gonna make a different bed. There we go. What's the benefit of specifying an error type? It's nice to have a full set of errors that you know are possible for handling them. It means also that you will get an error, a compile error, if you try to return an error that's not in the set. So you could try to make certain kinds of failures impossible. So if you want to, that's a good way to put it. So what a concrete error set does for you is it makes you decide up front what kind of errors are allowed. And if you fail in a way that's not one of the allowed ways, then code does not compile. So it helps you to write robust, correct code. It's also needed if you have a call graph cycle. Indirect recursion. Okay, so we have a create file. Where is this? Here. Okay. Wow, I really burned a lot of time on a trivial function here. That's my bad there. But let's move on to the next one. So now we need write all. And of course, this is going to be implemented as a helper around... Oh, we still want file. Okay, so now we just need the write function, and that's got to be added. Um, Thank you, Matthew. I didn't need you because the compiler told me that I had a unused parameter. Okay, now I did right. Now we need to populate right here. That one's going to be pretty straightforward. What lovely bug do we have here? 323, the function doesn't match. Okay, what's wrong? I bet it's const, isn't it? Yeah, discards const qualifier. What a nice error message. Okay. Oh, it actually builds. Does it run though? Oh wait, I guess I don't have a way to check if it works, do I? I can't read that. What about just raw at 1 instead of 13? How about that? Okay. I feel like that probably works. Seems short. Yeah, it is short because we're only doing one read, and we're just allowing that. That's fine. That's part of. We'll get there. Okay, not the focus right now. Although I suppose we can implement read all, which just is defined to. I don't want to get into that because I have this like fully addressed in well, let me think for a second. I was gonna say I deal with this problem in a branch and I just don't want to try to work on that branch right now. But let's just get the whole file converted over. That makes sense. So let's just make this a little bigger. And then we'll do read all. We'll define this however we want. How do we want to define this? Okay, yeah, we'll define it the same way. Okay, now this is basically a helper. Yeah, the reason I didn't want to do this is because I moved all these helpers over to buffered reader, which is the right place for them. So this is already code I'm gonna delete in my branch, but fuck it. Let's just do it for fun. Okay, does it work? I don't know. Seems a little short still, doesn't it? Oh, well, that makes sense. Okay. There you have it. That's our little example. Oh, new follower. I wonder if I can read this person's name. I don't know that one. I don't know that one. I think that one is you. Sorry, I can't pronounce your name. Would you need to also have a way to control what information standard that file stores? I don't think so. I think we just need file handles. What's next? Okay, so we have a plan. I want to get to the IO ring good stuff, and we're burning a lot of time on kind of like boilerplate. So, but the boilerplate works. So we have this thing running. We're using the IO interface for doing all this stuff. It does something, and we're just lowering it pretty much directly to boring old reads. Sorry, boring old syscalls directly. So let's take the next step and make this example work with our event loop thing, which means that now we need to go in and implement these functions in this implementation too. So let's do it. I'll make a commit because it's a checkpoint. Start adding IO. Okay. So let's switch over to our other implementation and watch it fail. Okay, obviously, yeah, we're missing these new interface implementations. So let's add them. We can start by having just a template. Thank you for the template. Let's do my favorite thing. And subpath, flags, panic, to-do, boing, boing. This one. Too many Asm clobbers. What? Okay, so now we're building, but obviously we're going to crash if we try to run it. Got it to do right there. Ooh, didn't get a backtrace. That's unfortunate. I wonder if that's a problem with the way fibers are working. Don't know. That's a problem to solve for sure. Could be incremental. Oh, that's a good point. What if I start it over? Oh, I guess that was it. Thank you. Yep. Although, yeah, that is still a little weird. Well. Yeah, it's still kind of broken, isn't it? Huh. Anyway, doesn't matter. We know what we're hitting. We're hitting one of these to-dos. Oh, it doesn't handle incremental debug info. Okay, I see. Well, I'll turn off incremental once we want to actually run it, I guess. So we'll just keep it while we're working on it. So let's start with open and create. So we can't just do a blocking call. That's wrong. What we need to do, the whole goal of this is always non-blocking IO. So what that means is we need to use the, in this case, the IOU ring API to request the file to be open. And then we need to yield to a different fiber. We need to, first of all, we need to register ourselves to get resumed when the task is done, and then we need to yield so that the scheduler can do something else. And then when we get resumed, we can assume that it was because the task is done. I need a response handling fiber to resume fibers. I don't know what that means. Yeah, I need a response handling fiber. Yeah. I think I know what you mean. I need a main loop, right? So we need to create a main loop. So inside init, we get called right here. And this is where we need to create our IOU ring instance. And then we need to have some kind of thread of execution. I guess that's the response handling fiber. You can handle responses on the idle fibers. Okay. I'm gonna need help from you, Jacob, on where I can insert my cursor and write some code. And I need help from Rockerager on how can we initialize the IOU ring. So we definitely want to initialize it here. Fiber is green thread, same concept. Oh, hey, thanks for the raid, Patrick GH3. Welcome to all the people. We are adding IOU ring support to our green threads userland implementation right now. We're kind of in the thick of it. Y'all jumped in while we're right in the middle of some code. So let's initialize the IOU ring. What context do we need here? Maybe I can figure it out from the docs. Okay, these are like the raw syscalls. Okay, I think it's this thing that I want to create, maybe. IOU ring init. Perfect, thank you. Okay, so I think this is what we want. Are you suggesting to ignore this type entirely? Or not? It's funny, it's kind of like almost exactly like our little IO instance, isn't it? Like they had to implement that read function there, which takes the self argument. Very similar, isn't it? Okay, so you are suggesting that we go ahead and use this this API. Okay, so it looks like we need init, and that's going to return one. Okay. Entries must be a power of 2. All right. What about flags? What could the flags be? Okay, we're gonna import this. Oh man, why do I have... Do I have to rebootstrap in order to get rid of this problem? Too many Aspen clobbers? Oh, I know what the problem is, because using the other zig over here for that. That's annoying. Alright, I have a solution. Alright, which commit is it? This one. Alright. 10 minutes, we'll have that error gone. What up? Another raid, damn. Everyone's out to get me. What up, Mudbound Dragon? Thanks for the raid. We are in the thick of it. We have this code here, which we are trying to make be non-blocking with MN threading using IOU ring. So we kind of have our code already. We had it working with a thread pool. Now I'm trying to swap out this like IO backend and have it still work the same. And I've never used IOU ring before, so basically this is turning into a teach Andrew IOU ring tutorial. Okay, so here we have this. Okay, I think I can just set it up right here. So I'll do ioring.init. Oh, I can just do .init, huh? Okay, so now we need, what did it say? Power of 2. I don't know which value to use. Is this like the queue size? I don't know. How about 64? Does anyone know what I should put here? You might not have seen that I did pick 2 commits, by the way. The one that we wanted was redistribute inline ASM limits, right? Too fast. I know. I love cherry picking. Cherry picking is the best. I also love cherries. Okay, IOU ring is initialized. All right, good job. I did it. What the fuck do I do now? So basically, I'm gonna need to. What's the kind of like game loop look like here? Like if I want to implement like close, for example, how do I do that? So I need this thing. Okay, what's this? User data. Queues but does not submit. Returns a pointer. Oh man. Okay. Oh, here we go. Okay. You get an SQE, then ring.submit. Do I want one SQE for everything? Returns a pointer to a vacant. What does SQE stand for? Sequence of queue entry. Submit can be a syscall. Okay. So they have batching of SQEs. Submission queue entry. Thank you. Okay. So is a SQE only one possible like operation? Shut up, Loris. That's not what it stands for. Yeah, one SQE per task. Okay, that is very helpful. Thank you. So get SQE is like get my task container that I'm gonna do my thing in. Okay, understood. Okay, let me just read this real quick. So it returns the pointer to a vacant SQE or an error if the submission queue is full. Oh, that's interesting. We have to deal with that. Okay. If the submission queue is full. Well, we would just want to block if the submission queue is full, right? Why would we want an error? Is there a way to block? Or wait, is there a way to... what would we do? So if we got a full submission queue, then we would want to switch tasks. But then how do we know when to resume tasks? Okay, we'll have to come back to that one. Follow the implementation of liburing, blah, blah, blah. Oh, sharp object set. Ultimately, you're spin waiting or sleeping here. Okay. They should just let you make it block. My thread safe ironing code isn't listed. Oh. Crap. Wait, this is not thread safe? Why the heck is it not thread safe? Oh no. I assumed it was thread safe. No. Okay, quick, put it in the standard library already. Or just put it in this branch. Man, there's a lot of problems with these documentations. Never say powerful. That's subjective. Also, don't reference someone else's library. Just explain how it works. Okay. Okay, so we're going to do get SQE. We're going to panic for now if it also doesn't have errors. Just tell me what the error set is. No. There's only one error on that one. Okay, that's good to know. Let's just try to get something on the ground. It's not going to be perfect. It's going to have a bunch of problems, and then we're going to try and refine it. That's the way it always works. But we got to start somewhere. So let's start somewhere. And the place we're going to start is get SQE, apparently. Now, so I'm guessing that I'm going to want to put... Let's start with just open file. I think that's nice and simple. I guess this is where it would have helped to actually do the thing that I was talking about, where we do the POSIX flags computations in this implementation, because we're going to have to do it now. That's fine. So open file, here we are. Let's create file. Let's get down there. Okay, I'm gonna yank this code for now. We're gonna have to clean this up for sure. But let's try and convert this over to IOE ring. So this is open. Or is it std.posix? Std.posix. We need native OS. Wait, we know the native OS, don't we? Yeah. We definitely know the native OS. Let's not kid ourselves right now. Okay. I'll just leave those because I don't know what the answers are. Loris, are you having fun being the troll in the chat for once instead of being the guy being trolled constantly? Up here. Must be a nice change of pace. What am I doing? Expected. Why am I expecting a semicolon here? Wait. Oh. Wait, what? My mind is breaking right now. What is going on? What the? Why can I not like just parse this? What? Oh. Okay, that was just making my brain melt. I had no... Oh. Oh, hello. Hello to all the new people. Yeah, it's been a long stream. We're kind of in the middle of something right now, but basically it's just the IOU ring tutorial at this point. Okay, moving on. This thing's still going. So the whole point of copy pasting this code is so that we have some flags now. Let's not do the locking thing right now. We'll say what was that? If what is this? Have flock? I think we need that here. Okay, I think I tied up those loose ends for a minute. Now, obviously we can't just call this function. That's what we're trying to turn into the IOU ring. So let's convert do I really not have any copy pastable thing here? Oh, that's super annoying. Cast data. Okay. So we have that thingy. This is going to go away in like a couple minutes when it finishes building the new commit. Okay, so now I guess what we need to do is make a SQE or something like that. So let's try calling that get SQE. It just gets one. Okay. And that can fail. Okay, let's make a helper for this. I'm just going to call it get SQE. I know. Oh, wow, what did I just type? Let's try that again. IOU ring dot. Oh, it doesn't even like alias the type here. Oh man, I have a lot. Okay, if Rocker Rager is still watching, I have a lot of opinions about this already. My goodness. Oh, it's just doing some logic in here. Maybe I should write that logic. I don't know. We'll come back to that. We're gonna write it at a bit of a higher level, I think. Okay, so what is this anyway? It's IOU ring squeak. Okay, so this one can't fail. And if the thing's full, then that's not thread safe. Ah, shit. Yeah, you're right. It's not thread safe, is it? Can you give me your code, or should I just put a mutex on it? One ring per thread. Oh, really? Okay, we can make that happen. I'm glad you mentioned that. In that case, I'll just put it in here then. A. Okay, and then init doesn't do anything. But we do need to init it, so let's find the part where threads are made. Was it called quota? Cap? There it is. Okay, here we go. Thread spawn. Let's go ahead and initialize that. Yeah, okay, obviously. Okay, there we go. One thread per IOU ring. Are you doing like one ring that a bunch of threads schedule on? I guess that's a good point. Let's back up for a second. Why does Expo recommend one ring per thread? Dispatching the completions across threads. Right, because one way to do it would be to have one ring and then each ring is effectively a kernel thread. That seems good then, right? Don't you want to just have like a corresponding kernel thread for each user space thread? Okay, does context have the current thread? No. Is there a way to get the current thread? In this case, you probably want only one kernel side thread for the whole application. Why is that? Oh. Okay, so it sounds like we should have only one ring then. Right? Sounds like we just want one IO ring. Okay, so then what do we do if it's full? Ah, shit, it's not thread safe though. Submission queue full. We'll deal with this problem later. Okay, but that's also not thread safe. Damn it. Should I just use a mutex for now? One ring per thread is probably better than a mutex. Okay, one ring per thread it is then. Okay, so let's do that. One ring per thread. Do we have a way to get the current thread? No, I removed that. Okay. Can I add it back? Or is that a problem? Oh wait, thread. What the? Oh. The main thread doesn't have a thread, so you can't access it from every thread. Good point. So I need a place to store the IOU ring for. Well, I guess I could put those in there, but then we need one for the main thread IOU ring. So we still need that one too. Okay. What is this number again? Init. Entries. Okay, we need to get the access to the corresponding IOU ring. So I mean, I basically just want to get access to the current thread or null then, right? So how do I do that? Just put it in a thread local. Yeah, I guess so. Yeah, all right. Do I really want like all the state in there though? Because isn't it a problem? Wait. Am I going to be doing like a slow thread local access every time I access a field or something like that? to get the pointer, and then you have the pointer. Okay, I see. Okay, so on init, we're going to initialize the thread local. Let's say main. Oh wait, that's not the main thread IE ring, is it? No, it's the thread local one. Okay, and then we have the thread spawn thread entry. There we go. Okay, so now we have a thread local one. Pretty straightforward. Handle submission. Okay, finally. This is an alternative to storing a pointer to the which is only worse. Yeah, that makes sense. Okay, so now we have our little helper method here to remind ourselves to solve this problem later. Okay, now we have an SQE. Now what do? We want to open a file. Open at. Ooh. Let's grab that. How come this can fail? Because the buffer can run out or something? Okay, so we try. Yeah, what are all the ways this can fail too? That's another question that I don't see here. Oh wait, this is calling get SQE. Wait, what? What's the point of get SQE? Do all of these do it for you? I think I just want to use this type. Oh, here we go. Okay, I'm gonna just use these as like little templates. Okay, yeah. That's much nicer because prep open at. doesn't fail, which is what I want. Great. Okay, so we prep openat, which is basically populating a buffer. Yeah, I'm seeing what's going on here. I feel like probably just gonna delete this entire library. This IO ring thing. It's not a good abstraction. This is the good abstraction that we're making right here. It's like both too high level and too low level at the same time. You know what I mean? This one's at least too high level, but not also too low level. Okay, so we prep it. Yeah, we have FD. We got path. We got... did we convert the path to a proper string yet? No. Subpath? No. Okay, so that one we need help with. Where am I? What am I doing? Open file. Here we go. Oh, crap. We have to have path live, don't we? The cool thing is that when the queue is full, you can yield and reschedule yourself instead of resorting to polling and doing nothing else. Yes, that's what I was thinking that we would be able to do. Maybe like, but I mean, effectively it's like sleep, right? Like when do you... Oh, no, because it's our own code. If the list is full, it's our list. So we just keep track of when we remove something from the list and then go through the fibers that were waiting to submit. We have a waiting to submit queue. Yeah. This is going to be nice. This is going to be really nice. It's the kernels list? What? Okay, same deal though. It's both, right? It's shared memory. Like the kernel and the user space are looking at the same list, right? Point is, we know when a list gets smaller, and that's when we can check to see if there's anyone waiting to submit work. We don't know when a list gets smaller? Why do we not know when a list gets smaller? Because it just changes in memory. We'd have to poll. Well, wouldn't a good time to check if the list got smaller be after like pretty much any operation completes? Because operations completing is what's preventing the submission from being deleted, right? Okay, anyway, it'll be very interesting to make this be more efficient. Okay, but I think we have a problem here. I see. So in a blocking case, we can copy the path and add a null terminator. I don't think we can store path on the struct, right? Or is prep copying the path into some buffer? Because if there's another opportunity here, which is maybe not a big deal, but if this is copying the path into a buffer, that could be our chance to add a null terminator. So that's another reason to dig in down there. They don't store any string. If this path isn't getting copied onto some buffer, then I don't think we can store the copy on the struct, on the stack, right? Oh, the fiber stack stays alive. Right. Right. That's the benefit of doing it this way. Well, I guess that one's kind of equivalent. Okay, anyway, let's move on. So I think we just want to do this one right away. Wait, why can this fail anyway? Name too long? I think... Yeah, I guess that is the right... Okay. Yeah, I think name too long is the right one. All the scopes are the scopes of the things. Yeah, it's actually really nice, isn't it? Okay. There we go. So I think we did need to do the null termination then because it's not being copied. So we prep the data. Now we can set user data. I'm guessing this is like a usize. What do we want here? I don't know. It's a mystery. Fiber pointer, rights, of course. Which is this one. You delete the logic that lets me get the current fiber? God damn it. Doesn't yield need to know the current one? Because not every thread is on a full fiber. Oh. So your point is that the main thread might not have a fiber pointer? You could just make it have one. What do I do then? There's no fiber pointer. Ugh. Okay, then we prep it, and then we... What do we do? Do we submit it? Enter. Field parent pointer from current context. Oh. Current context, and then it's basically it's this relationship. Okay. Okay, so then I don't think we want to call it enter because that's going to make a syscall, right? Yeah. Is it blocking? If it's non-blocking, then I think we can call it. What is to submit? Is that a number? No. How many SQEs you've obtained and filled in? Wait, how is it not tracking that? How do I know if I filled them in? Is this one filled in, or did I not fill it in? Min complete flags? What are the flags? Okay. Well, since we have one IOU ring per thread, then I'm pretty sure it's one. I don't know what min complete is. I think we should only call enter on idle fibers. Then we can batch multiple operations. Oh, that sounds nice. So then we would track the number of prepped things. When the queue fills up, everything yields to the idle fibers. Are you talking about right here? I think I'm kind of stuck conceptually. I need to do something that works, and then I can refine it. I think your idea is too powerful for me right now. Incomplete is how many ops you would like to be done. Oh, that's nice. So if I say 0, then it's non-blocking, basically. And then it doesn't seem like there's any flags. There's a bunch of possible errors. We'll have to figure out how to expose these kinds of errors. I think we might need to handle them asynchronously. And then, yeah, because you kind of really want to only handle open errors from this function, if you know what I mean. Most of them are programmer error or please retry. Okay, got it. I'm going to put a to-do on that for now. I really need to get something working before I can refine it. Flags mode. Okay, and then that's gonna, oh, that returns us a value, right? So now we need to switch tasks, right? And then how do we come back? I guess we would have needed to store this somewhere, right? So we need like to have a queue of waiting waiting fibers on these pointers. completion queue. Let's go look at the completion queue. Ooh. Oh, I was supposed to initialize those, wasn't I? Okay. You want to yield without getting rescheduled so that the completion can resume you. Right. Well, who's going to get the CQE? Someone's got to call. Is it copy CQE? Is this like check if anything's done, basically? Oh, this is blocking. Okay. An idle thread. Right. So the idle thread is going to do this. And then whenever you get them, it resumes everything on a different thread, I think. Okay, I'm starting to get it. Should we go write the idle thread code then right now? FD, what is this? There. Wait, how did I not even use this? We can finish this part. I should yield. Right. Okay, so we did schedule ourselves. Right, so this is going to communicate with the kernel. So it's not like we leaked anything. Like this is going to be able to find us again. So now we can just yield. And how do I yield? I think this is how I yield. Oh, optional fiber? What kind of fiber is this? Register awaiter. Oh, that's who we want to resume. Okay. And then I don't think we want this actually. Like we just want this. And then we should not be put onto a waiting list. Right? Yeah. Okay. Okay, so we yield, and then when we get resumed, we're done. Where's the result though? How do we exfiltrate that data across the yield? Oh, it's all in scope, isn't it? It's all right here. Our result buffer? What's our result buffer? Oh, you want to repurpose that result buffer also for IOU ring results? Okay. Yeah, I guess that makes sense. Yeah. So then we have to decide. Okay, but where's the result in the kernel ABI? So we get the CQE, and then what? We get the user data that tells us the fiber. Result code flags. I don't see like where it would put the. So walk me through this. We're gonna call basically this. We're gonna get one of these. Put the file descriptor, because we're calling open, so we need the result. All syscalls return an int. Yeah. So where's the int? Oh, it's this one. Okay. I see. Okay. All right, I understand. So in the code that we access this data, we'll basically just copy this into the result buffer at the beginning. Okay, that works. So we'll do result pointer. Maybe we don't need a current fiber. How do we get away with that? Okay, then we should be able to just read that as the result. And that's the answer. So then we can do that. Wow. Okay. That's not so bad, actually. It's not doing that nice batching thing yet, though. Need to check for error. Thank you. Yes. Need to check for error for sure. Probably what I'll want to do is separate out this logic into a different function so I can just call it. I might as well just do that right now, actually. Or maybe it should be handled same. Oh, it's got that loop in there too. This logic right here. Oh, but that's where the loop is. I'm gonna crimp this for now. Crib this for now. So that's actually an I32. Wait, so is this result, is that just the syscall? Did Axpo just not be ridiculous and just gave us the syscall result instead of trying to do some Erno thing? Oh, thank you so much, Axpo. I love you so much. Oh, I love it. Oh, we got another raid. Damn. Oh, welcome everyone. We're doing basically intro to IOU ring with green threads. I'm just feeling very happy that I don't have to air know this right now. All right, so I just need that thing where it checks this logic here. I guess I'll just do this. Before Rust had Tokyo, ended up building threading into the async await macro, so when we're done. That sounds tricky. Yeah, this stuff is kind of bending my brain, but in a good way. Okay, so this is going to unwrap our syscall. It's already signed, isn't it? Okay. So I think I just want, if it's greater than 0, then we're good. Otherwise, we're going to have to do switch. Never mind the continue. Are we able to get e-inter from doing IOU ring? That's not possible, right? I'm gonna put a to do on that one too. He canceled. Oh, snap. Okay. Canceled. That sounds awfully related to cancellation. Thanks, Sam Griffin. Have a good night. Yeah, I'm not very good at guitar, but I like music. Sometimes I try to play. Okay, I guess we'll try to add. I guess maybe we'll have to add canceled to. That's a question we'll have to figure out, because I was using open error, read error, or whatever it was. Yeah, file.open error, which I guess now could include canceled if you do it through IOU ring. Oh, we got to cross that bridge later. I'm sorry. I added error.canceled to all my functions. So what project are you working on? Are you just doing what I'm doing in parallel but faster and better and not on stream? This is a while ago. Okay. Aaron's 24/7 doing nothing. Unexpected air no. Okay, I think we're getting somewhere. All right. Let's figure this out. So we have the submission, which isn't doing the nice batching that we know we want to do eventually. We yield. We need the idle thread, right? Should we move on to the idle thread? Actually, I should probably fix these errors. before we move on. These can all fail? Oh. Why does this possibly fail? I just hard codes 1,000? What is going on here? Oh man. Init params. Oh, there's a lot of code here. Okay. I have a feeling I'm gonna want to revisit all this code. For now, it's too much for my brain. I gotta use it though. So let me just try these. That's not good. So I see. Yeah, that's what I want. This needs to also... Is there any resources there? I don't think so. Or maybe? I'll put a to-do in there. Wait, no, it's of course a dnit. Okay. What does yield do? Yield is a little tricky to understand. It is implementing green threads. So there's some ways to configure how it works, but in essence, it's going to run this code down here. Which is different for each architecture. It is... Oh, this is different than last time I looked at it, so I'm probably going to explain it wrong. It is going to adjust the registers of the CPU so that without going into the kernel, without doing any syscalls or anything, it's going to adjust the registers of the CPU so that it is no longer working on this stack of stuff, and it's now working on that one. And depending on these parameters here, it might schedule the previous one or not. Yeah, so it's a user context switch. Excuse me. Okay. I'm trying to fix these compile errors right now. That's where I'm at. Oh, somebody put a explicit error set on here. Okay. Out of memory is the only failure. How about I just make that be anything? Okay, and then this one. Oh. Ooh. What? Shit. I have it in multiple places. Yeah, okay, so each thread starts it, and then... Well, what do I do if I fail here? It's another panic, I guess. Just return. Oh, that's nice. Good point. Should I print something? Though? Maybe? I suppose it is more like a warning, isn't it? Okay, let's keep going. Fs, is it .fd maybe? Okay, next I need to turn that into a pointer. Next. I think I messed up the order of these. Next. Prep open at. Did I mess up this order here? FD path flags mode. FD path flags mode. Expected type. That thingy. Oh, I see what's happening. Well, that's why I made these. OS flags. Okay, there it is. Just to confirm, yield saves the current context, switches to somewhere else. Sometime later, when task SQE finishes, you would look up context and resume it. Yes, exactly. So that's why we save this. This pointer, we can call yield and resume here. So this yield will yield indefinitely because it's cooperative. It's cooperative coroutines. So we'll never resume after the yield unless a different fiber calls yield and passes our fiber pointer. So by putting it in here, we're planning for a different fiber to check the completion, grab this back out, and then call yield itself, passing the data in here. So the nice thing is it never wakes up if it doesn't need to. Well, it just kind of makes sense. Oh, right. Okay, so of course we need to do int from pointer. This returns a number? What does that mean? Returns a number of them submitted. Would that number ever be less than 1? I never submitted? What? What's the number do? Does that return like me? I don't understand this number. Returns the number submitted, but it's not the submit call. The number that the kernel has processed. Aha. So that means that if this number is greater than 0, then if we have fibers waiting to submit, then we can resume them. Okay. Okay, we don't want submit and wait, we want submit. So now we do submit. Oh, I see. So the SQEs are already all queued up. I still don't think you should call enter. Okay, well, let's not call enter then. What should I do? Should I just call submit? What does enter even do? I thought enter was submit. Okay. But why should we block? Okay, I see. So submit does not block, and it returns the number of SQEs submitted. Should I assert this or not? I can't tell. Also, how can it fail? Submit and wait 0. Oh, this just calls enter. Look. Flush SQ. Okay, so flush SQ is basically what we want. Okay, so how can submit fail? Where's my failures at? It's basically enter. Okay. Oh, right. As soon as we submit, we aren't yielded yet. Okay, so this is the same problem as async await. So I can probably go look at that code. What's up with this int cast? Ah. Okay, we got the compilers out of the way. So yeah, good point, Jacob Lee. So the problem is that the way we're going to get resumed is we put this user data thing in here, we call submit, but then the moment that we do that, a different thread might get the completion, might read the completion, find the user data, and then call resume, which would have worked if we got to the yield, but we didn't get to the yield yet because we still need to submit. But we can't submit because we need to yield, but we can't yield because we need to submit. We need an atomic yield and submit. We need to like prepare to be resumed from a certain point, and then yeah, you get the idea. Bring back pending task. What are you talking about? Oops. Okay, so you're saying replace register awaiter with pending task. Oh, I see. Okay, and then I'm gonna need help understanding how to edit this code. So then we have none. We have register awaiter. Oh wait. Yeah. Why is it a star question mark star? Should it just be this? Okay, and then should we rely on thread local to get the IOU ring, or should we pass it? We should probably pass it, right? So then this logic will have to do the IOU submit. Yeah, okay. Oh, you just passed the message straight through. Where does that get used? Handle. Okay. Every context switch has to process the message. I see. Because there could be something important to do. Right. So in that case, we do have two things here. Yeah, that's not going to be able to get read off the thread local, and that needs to be passed. I don't know why we need fiber. Oh yeah, you're right. It's the same thread. You're saying that it's going to switch to the same thread, so just read the thread local. Okay. But it's also fine to avoid the access. Okay, well, I guess since it's free, let's avoid the access. Pending task. And it might be null. Okay. And now register awaiter is not null. And that should be the exact same type. Okay, now we also have, well, we have none. We also have IO Uring submit. Ah. So this handle is being called on the same thread after the switch. It's nice. Okay. So we're about to do the new thing, but first we have a chore. Oh, and let's... What did I call it? IO Uring submit. I see. Okay, beautiful. So we have a way to just do stuff on the other side of the yield. That's a nice primitive. Okay, what about this? So, so this is probably wrong. I don't really know what to do with this information. The idle fiber's main job previously was to do the pending task. Okay. If we fail to submit, how can that fail? It's to submit and wait 0. I think this can be made infallible, actually, right? Because isn't this going to be false sometimes, depending on our flags? I don't think we're using pull, so Um, wait, so it's gonna wait. Can we guarantee that we'll never do this? Oh yeah, okay, perfect. Yeah, flush SQ. That's what I want. Yes, 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 yes. Perfect. Returns what? Number of all pending events in the SQ ring for the shared ring. I don't know what to do with that information. Okay, I'm happy with that for now. So, let's try it. No, we can't try it yet. We gotta have the completion side of the things. Okay, so where do I put the code for the idle thread? Is it just like a actually separate thread? Idle stack? What's this being used for? Oh, it's an idle fiber, not a idle thread. Okay. So we have submission implemented. What we don't have is checking for completion. I think we need that. Should we have... Well, shouldn't every thread be checking for completion? Right. Each thread has an idle context. Okay, I see. So then... what are we jumping to here then? There it is. Idle entry. Wait, that's the main one. Why is main idle entry separate? Oh, I see. This is never initialized? Oh wait, current idle context. Oh yeah. Next function down. Oh, damn it. Where was I? Oh, here it is. Main idle calls idle. Thread entry. Oh. Okay, so in the thread entry, we just start idling at the end. Right, of course. Okay. And then main idle is different, though. So that is where the message is handled, but not on this one. Yield. Okay, so first we yield. Then there's an exit awaiter. I see. Trying to shut down. Okay. Idle count. Oh, and then we wait. We wait on a condition? Right, yeah, because if you're yielding, you're going to do work. There's something's going to be switched to. So we can't just be switching forever. We do have to wait on a condition. So we broadcast on that condition, or we signal when we schedule something. Okay, I see. Yeah. When this queue is empty, we switch here. I see. Okay. At some point, I think we probably want to have thread local work queues that steal from each other. But that's not what we're working on right now. Right now, I'm just trying to find out where I can put checking the completion thing. So I think what I want is Wait, what do you mean this is only switched to when the queue is empty? Because the thread enters and then we immediately go into idle, right? Oh, I get it. So calling yield will just yield, 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 yield. So if you come back from yield, it's because there's nothing else to do. Yeah. So is yield where we want to put our check for completion? I feel like... Or maybe we would rather do all our yielding first, and then if we're going to go into idle, then we check for completions. Right? So like checking for a completion is a sleep operation. You'll have to move the condition to the IOU ring later. So it replaced wait. So instead of here, we do completion. And then instead of signal, we do like interrupt. Okay, let's try and figure out how to do that. Okay, so this is our sleep basically. Wait for completions to become available. Yeah. I guess this is kind of a gamble too, right? Because if you pick a higher number, then you are more efficient because you're batching, but then you might end up still waiting before you might end up waiting even though you could be doing work. I guess we put 0 as the weight number, right? Oh, wait for at most. At most. At most. I'm trying to figure out how to get the semantics I want. What I want is give me all of them, but as soon as possible. So if there's 0, then wait. But if there's more than 0, then give me all of them and don't wait. How long before? So just pass 1. Okay, I see. So 1 gives me the thing I want. Okay. So is this what I want? Copy key QEs? I think so. And okay, so we're gonna use this. Could switch us threads, so we do need a we do need a load here. Idle fiber only runs on one thread? Oh. Wait. But we have more than one. Switch to this thread's idle fiber. Oh, I see. So this fiber only ever runs on one thread. I see. That's what you said. Okay. All right, and how can this fail? There you go. It's enter, I guess. Okay. Okay, so if we fail to get the completions, why can't I call enter? Click that. Yeah, it is all kind of like try again or programmer error. All right, now how many of these should we have? They're about 16 bytes each, and for each one, we're going to loop over it and yield, maybe, or I passed the number to init. What are you talking about? Are you talking about this one? It's the most you could ever get. Oh, I see. Okay. Okay, that's fine. So there's still okay, yeah, but then what we want to do is figure out Hold on. Oh, that's not right. Okay, and then number, okay. Right, so now we have these, and each one represents a fiber that we want to resume. So we could, pretty sure, we could just iterate over these and yield. And don't forget to copy the, let's just call number to result buffer. And then basically yield based on the user data. But wouldn't it be better if you want to schedule all of them? Right, schedule all of them. Yeah, that's what I want to do. And then don't forget that we want to be able to interrupt this. Is there a way to interrupt this? So, because it's kind of like wait, isn't it? And then like the signal gets, previously we were calling condition.signal to wake up here. Now we would like to call wake up. You put something on the ring that completes and you read the completion. Right, of course, of course. So I just put not. Boing. A no-op is more useful than may appear at first glance. Ooh, it's a very mysterious dot comment there. Not helpful, but it is mysterious. Okay, so that means we don't need to worry about that. What about this mutex? I think it's just this, right? I don't know how idle count will be affected by this change. Remains to be seen. Okay. So it's read by schedule here. I'll just leave it. I'll just leave it how it is. So I think this code's done. No. Don't forget to copy the syscall number to the result buffer. Okay, so we have the CQE. We have user data. We have res. Isn't that mutex block just doing nothing? No, it is protecting this variable. Oh, I see your point. Idle count is now messed up, isn't it? Shit. Yeah, just change it to atomic. Yeah, I think that's the right move. I'll just do this before I forget. There. Is it important that this number is subtracted as soon as possible? Probably. Should be incremented while sleeping is all. Yeah, okay, so there we go. So then we memcopy fiber.result pointer. And the source is cque.res. You know, maybe a better idea is this. Okay. There. Decrement it as late as possible. More like it should not be incremented while yielding. Oh, okay. So okay. All right, I think this part's done. And now the NOP. You only need a NOP when everything's idling, and then handling a NOP CQE too, huh? Right. Okay, so here see the signals? For when to NOP? I don't know what you're talking about, sorry. Oh, right. Right, so it's only going to need to send a NOP if everything's idling. Or if anything's idling. Yeah, that makes sense. So, but if everything's like moving and grooving, you don't have to send any NOPs because it just queues up. Yeah, that makes sense. We don't need this. Wait, what is this mutex protecting now? So the mutex is protecting the queue. It's not protecting idle count anymore. I think the mutex can stay. Yeah, it's protecting Q. Is there another signal? No, that was it. Okay. Now, I guess... Oh, there's a broadcast? Okay. So this one was not a broadcast. This one was saying only wake up. Wake any thread, which we can't really do. Right. Well, we would rather just wake up only one thread. But we have to pick one. We have to pick one of the IOU rings, with which there's one per thread. And then we have to wake that one up. Might be good, because I remember when I wrote the epoll version of an event loop, and how I ended up making it was like the kernel got to choose which thread to wake up, but it always made bad choices. I thought it would make good choices, but it didn't. So maybe having that be in application space isn't such a bad thing. Maybe idle count should be an atomic IOU ring of the idling ring. Oh, that's a neat idea. So would it only store one? What if there's more than one idling earring? Maybe it should be a linked list, an intrusive linked lists of IOU rings that are idle. So then we basically just pop one and then wake that one up. Oh man, I don't know what I just pressed. Can you put back the previous idle with exchange? This one? Oh, I think I see what you're saying. Yeah, you're a little bit ahead of me. I think that's the move though, right? So instead of idle count, then you have basically just a singly linked list of idle fibers. Oh, I see the problem though. So the problem is that you want to mark yourself idle, but then there's a race condition where you put yourself in the idle list. Wait, no, that would be fine. So you would put yourself in the idle list first, then you would go into here, and then if the race happened, you'd go into the system, but then you'd immediately get the NOP, and then you come right back out, right? I think that's a good idea. Well, let me make it protected by mutex first, and then we can try and make it atomic instead, yeah? So idle. So we bring back the mutex. Could be a bit set that you scan for an idle thread and look up the thread by index. That seems good because the number of bits will be small. In what situation would it be multiple threads? The one that we're doing right now. This is, you know, what they call MN threading. So you have M threads, or you have M green threads on top of N actual threads. So the situation here is that you have N number of threads idling, and they go to sleep here, but they need to be woken up so they can do more work here. So you get to send a message. All right, you think we should do this bit set thing? Let's do a bit set then. So we're gonna mark here that we're going idle, right? So each thread needs to have a we need to remove ourselves out of order. Oh, I see. So every thread needs to know which index it is then? Yeah? Should I move all the thread local state into one thing? Like, is that fine? Or should I just do another one? Same thing. Is it? Oh. Well, if you accessed... Oh yeah, I suppose it would be the same thing, huh? Yeah, okay. Thread. Oh, good point. Yeah, thread index. Right. But we need to reintroduce the main thread as a thread. item and skip it when joining. Right. Okay, let's do that. Next starting index is already stored, of course. We'll come back to that, don't worry. Okay. Let's go patch up these references here. Not that one. Okay, so your point is that we'll need to allocate kind of a dummy thread here, right? So, like, what's going on? Get CPU count? Max get CPU count 1. Why would this change the CPU count? Oh, I get what you're saying. Wait, threads bytes? Oh, are you saying allocate it also for the main one? Oh. Okay. Okay, so we're not doing -1 anymore. Now we're doing max. Yeah, we're gonna get there, don't worry. Okay, is that what you're saying? So at least 1, and we're not subtracting 1, threads bytes, right? All right, I need to see some errors. Oh, right, of course. Dnid also needs to go. Yeah, first one is okay. This thing's got to be fixed. Okay, so we're on the main thread here. Okay, now here we need access to current thread as well. All right, we gotta initialize the in dnet. Oh, we have a dnet bug. Okay, one sec. Right, so items ln. Nice. Okay, good catch. Okay, and then we need to initialize the thread local that says the thread index. I think we have to pass that here, so that's going to be -1. First one will be 0. Oh, I need to I'll pass it instead of thread, right? I think we also need to do the add one for the main thread. So here we have the capacity correct. This is just going to be an out of bounds error. There. Okay, I think we're starting to get there. Okay, so now we have the red. Current fiber. Okay, I probably made a mistake. Idle count is no longer a thing. Okay, so we need to update the signal and the broadcast. Oh no, it's an extern struct. Oh. Should I make it a pointer? I don't know if I can. Yeah, okay, I'll solve this problem in a minute. Let's come back to this. Let's try to focus on the signal, the idle broadcast thing. We'll come back to the pending tasks thing. Okay, so the bit set idea. We need to have a bit set here that represents idle stuff, right? Idle U-rings. And on my computer, U32 would do the trick, but on a computer with more CPUs, we would want more bits. How should we structure that? Allocate it in the init function. That is a great point. Should we use one of the standard library bit sets? I don't know if they're good. Yeah, it's free to bump that. Needs to be atomic. Ooh, okay. So let's do this then. Okay, and we can allocate that in init. Okay. Oh, that could even just go. Wait. What is this for? Oh, okay, whatever. Right. But we need to round up, so okay. Expected 3 arguments. What? Type. What? It has an error? Oh my god. Div seal. You have disappointed me. Okay, so n threads plus the size of size minus 1 divide by the size of size. Okay. All right, we're back. Idle IOU rings. We've got it. We need to initialize it. All right, where are we at? What up, 780 Chris? All the other programmers doing AI stuff. I just think that programming, for me, one of the most fun things about programming is like finding the sweet spot, you know? Oh my god, vibe coding and event loop, that would be that would be nuts. Yeah, for me finding a sweet spot is a really satisfying kind of programming where you make certain trade-offs and like, yeah, you can't solve everything for everyone. Like it's got this trade-off, that trade-off, but you found the sweet spot, you know, you found like a really good place. It's very satisfying, and I don't think that's where you get to with AI slop. Change uses of old idle count. Yes, okay, so thanks for keeping me focused. I'm starting to lose my stamina here at the end of this 6-hour session. Okay, so previously we were doing signal here in order to wake up the idle waiter. Now we are going to we're not going to have a mutex locked. We're not going to have idle count either. Here we want to atomically check for any non-zeros, right? That's not atomic. There. And then if atomic load oh, it's right here. Pointer ordering we aren't protecting the logic around it. We are actually just interested in the value. So we can use the weakest atomic order. Any idlers okay, so if it's not 0, then we found at least one idler. Are we just trying to find if there's one? Oh. We need the idler index to look up its ring. And then we're going to put a nop in it, right? Yeah. Well, what's the race? Because isn't it pretty much always safe to put a nop in there? Or is it a bug? Oh, because IOE ring isn't thread safe. Oh. But well, let's just use the I see. Right, okay. Well, okay, whatever. We'll keep the mutex locked. Fine. So then we have to lock it in the other place too. Let me just get this logic banged out here, and then we can move it around. Okay. Well, before we move on, though, so we're scheduling one thing. We've already scheduled it, and then the question is, should we wake something up? Well, we only need to wake up one thing, I guess. Although, wouldn't it make more sense, like, because I'm thinking, like, we're going to find more than one idler per chance, and we could... We need a few texts? Okay. Oh, man. I think I'm at the end of my stamina for now. I think I need to go take a break and have some food and walk around and stuff. I don't think we're going to see this working on the stream. I feel like I'm kind of starting to understand IOE ring, though. It's, like, simpler than I thought. I mean, yeah, it's actually a lot simpler than I thought. And now I'm realizing that the library around it is kind of silly. It's like... They tried to make it a higher level, I guess, but I don't... Just keep it low level. What are they doing? I don't know. Yeah, I think I'm going to wrap this up and do something else, but I still want to see this through at some point here. So I'll probably... I'll probably work with Jacobly and throughout the week, and then maybe we can see a demo of what happened next time. But to give an overview, how this would have gone down is, so we add a idling set here, and then we change these this schedule to wake up an idler, and then where was that other part? Yeah, and then down here, it basically just wakes up because it gets a NOP. And then I think we'd be able to run it. And then all of that, and all we would be doing would just be opening a file. Still pretty cool though. And then, well, yeah, we could probably get this thing fully working pretty soon after that. But, yeah, I think for now I'm just gonna make like a WIP commit. Got carried away by NOPs. You're supposed to use a few text, which is a condition. I don't even understand that suggestion. How could we get away with not using a NOP? Because we would need a NOP to get out of this, right? How are you gonna use a few text? Are you saying that? Yeah, it doesn't support few texts in here, obviously. The condition implementation. Okay, so it's just some atomics, and then there's a mutex. I mean, oh, we queue a few texts to the same memory on every ring locally. Wait. Am I forgetting something? The futex wakes unless there's a you make the futex sleeps if the number is expected. So we check if there's anything, and there's nothing, and then we go to sleep while making sure. Oh, because it's just in memory, right? Because it's sharing memory with the kernel, so we can use a futex. Of course, that's beautiful. Yeah, okay, I'm with you. Yeah. I'm definitely out of stamina, but I got it. Yeah. So I think I'll just make probably like a WIP commit. Do you want me to, Jacob? I know you've been working on this with me. Do you want my broken ass WIP half typed code or no? Or do you want the commits up until this one? I mean, there's some work in there. Put up as a separate whip commit. Yeah, all right, sounds good. All right, well, I think I'm going to do that. Well, thanks everyone for watching. Yeah, that was a long stream, but Ring's really fun. I was excited to learn about it. Yeah, we'll see. So I think I'll give this topic maybe like another week of my time-ish before I go back. Because I don't really want to change the roadmap. Like, there's all the stuff that I've been wanting to work on for the release cycle. It's not unchanged. You know, we have our priorities, but I just saw this vision of like, oh, maybe we can solve the async await use case and just kind of have a plan forward, even if we don't finish it until some of these other things are done first. So I don't know. I think it's worth kind of like doing a proof of concept while I've got the energy for it. And then I'll probably just go back to working on, you know, incremental ARM linker stuff. You get the idea. But hopefully now that I got my computer fixed, I can start doing more of these streams, maybe like once a week ish. So thanks everyone for watching. I'll see you next time. Should we raid somebody? We got raided like 1,000,000 times on the stream, so it's only fair, right? Oh man, I don't know who these people are though. Yeah, onion ring and futex is pretty sweet. I don't want to send any people over if I don't know the person and I don't watch any streams, so I'm sorry. I think I'm just gonna call it. Hope you all have a good night. See you next time.